Okay. Yeah. Got it. And then I will share the slide. Wait, where to share? Oh, share screen. Okay. Share. Okay.
Okay, we can see your slide.
Mm-hmm.
Slideshow, yes.
Okay. Is that okay?
Okay. I think we have just 1 minute remaining, then I'll start.
Sure.
Okay. Good morning.
Good morning.
Morning, everyone. Welcome to our special lecture, visiting lecture project at Prince of Songkla University. And this is Shahriar. I'm lecturer at Prince of Songkla University, Faculty of Environmental Management. And today we have a special lecture from Malaysia. So before I invite our facilitator, I just would like to briefly introduce her. She is working as a lecturer at Faculty of Environmental Build Management and Department of Urban Planning at the University of Malaya. She had graduated University UPM, University
UTM. Yeah, University Technology Malaysia.
University Technology Malaysia. She's working last 3 years at University Malaya, and she tried to develop the policy for urban planning. She has experience also many based on the social science. And please help me to welcome our today's facilitator, Dr. Hashimah Lim. Welcome to On Board, Dr. Hashimah.
Okay, hi everyone. Thank you, Shah, for introducing me. So as Shah mentioned, my name is Noor Hashimah Hashim Lim, but you can call me Shima. And yeah, I'm currently serving as a senior lecturer under the Department of Urban and Regional Planning in Faculty of Built Environment in University Malaya. Okay, so today we will have like a run through of a very simplified version of what structural equation modeling is, but not really. I made this. I devised this this workshop to be from start to finish. Yeah. So okay, let me show you the agenda first. Okay, so for the first, yeah, let me stop my video, yeah, because I want to look at the slides. Okay.
Yes, you look beautiful. No, don't worry.
Thank you, thank you. Okay, so for the first part, will be introduction. So this part, we will spend about 50 to 60 minutes. So if anybody has any questions, you can ask towards the end. And the objective or activities that we are going to do is, I'm going to explain how you are able to translate your literature review into a framework, because most of the time we will jump straight into research methodology, where we will go find the analytical methods, and without understanding or without coming up with a framework that can guide us towards or throughout our project or our research lah. And then we will understand what sort of situation it will become, what sort of pathways or which direction should it go, and which type of graphic will tell other researchers of what you meant by what you show in your graphic. Because if you have seen structural equation modelings, all the AMOS or PLS and all that, you will tend to come across graphics of circles, rectangulars. So what do they mean, right? And then they all have meanings, okay? And then at the end of it, I will show a case scenario, and then by the end of it, I will show how each relationship or how each findings from your literature review, you are able to build the framework, all right? Now, and then by the end of it, I will recap the important points, and then probably if we have time, we will open for question and answer, all right? And then the second part, another 60 minutes. So the objective is to figure out your hypothesis. So from the literature review, you build your framework, and then from the framework, how are you going to, or whether would you want to be selective in what sort of hypotheses you want to come up with, okay, from the framework. Yeah. And then we will pretend that we have gone through the survey, sorry, and then we have the data ready. So we will, I will show like step by step, like literally step by step, from data preparation to checking for assumptions. So we will go through the missing data. We'll check for unengaged responses, outliers, normality, which are skewness and kurtosis. And then we will go into, when the data is prepared, we will go into exploratory factor analysis, where we will do some iteration until the pattern is clean. And then we will test for data advocacy, and then we will also test for data validity. And here there are two types of validity. Actually, there are many more types of validity. There are experts validity, but however, because today we are focusing on SEM, so I use a statistical type of validity. Okay, and then lastly, reliability. I'm sure most of you have heard of Convex Alpha. Yeah, so that's what reliability is, right? And then we will have a break of another hour, which is from 12 to 1. Okay, we will have our break. After our break from 1 to 2, we will have the third part. I call it part 2B lah, because it is part of the SEM. So this one, I will spend another 60 minutes. The objective and the activities are to conduct, like I will show a very simplified and brief run through a live demonstration of how to do confirmatory factor analysis. We will do invariance tests, we will do common method bias, and then optional, if we want to impute the data, we can impute the data. It's just a few clicks away. Okay. And then lastly we'll come to the structural model after everything has been explored and confirmed, right? So structural model, we will go through the multivariate assumptions, the how to add in the control variables, and then how to build the direct effects and how to see our output. Yeah, if we have time, then we will explore a bit on the indirect effects, which are mediation and moderation. So I'm not sure at what level the audience are at the moment. So if it is possible, before we start, may I know if the participants, have you gone through the entire process of SEM before, or are you just starting out? And are you doing a master's? Are you doing your PhD? May I have like a little bit of indication of where you are? If anybody were to answer lah, but it's
I
fine.
would like to volunteer. Just tell your name and which grade you are. Just tell that one. That's okay. One by one. Who'll start first? Rosie?
Good morning, sir. Good morning, ma'am.
Hi, good morning, Rosie.
I'm Rosie's sister. I'm pursuing my PhD. Good morning,
you're doing
ma'am.
your PhD. Okay.
I'm PhD students at PSU.
Okay. Have you ever I mean you want to do your research using SEM, or you're just listening in to explore, see whether it applies to you?
She's looking actually at SPSS.
No, actually, yes. I'm trying to learn how to use SPSS for my data.
Okay, it's fine. So I thank you, Rosie. So I assume
Thank you.
thank you. So I assume that everybody is just starting out. So I will not use like big terms because those are pretty advanced. So I will just explain in a very simple, using simple words. All right. Now, without further ado, let's start. Okay, so now part one. Right. Maybe I stop my video. All right. So part one. Okay, wait, how do I make this disappear? Okay, now, before we do SEM, we need to build a framework, a theoretical framework. And this theoretical framework can come from literature review. It can come from a pre-validated, pre-reliability tested framework. It can also just be a conceptual framework that you are interested in to find out. But whatever it is, if you want to do structural equation modeling, you have to start with having a framework. You have to, it is, like I mentioned just now, it is to guide you to see which variable is related to which variable in what direction and all that, right? So as an example, so I'm showing here, the example is that I am interested in understanding why a person can become fat or skinny or in between. So this was my PhD thesis actually, all right? So at first I started out like very innocently with a question in mind, okay? And then after we identify the thing the issue or the problem or the topic of interest that I would like to research on, then we have to make things measurable. So fat and skinny, how to make it measurable? There are many ways, of course. There are waist circumference. You can see the maybe the diabetic or the tendency of having heart disease, like indications of being a fat person and a skinny person. However, because I'm not from a medical background, so I use BMI, which is justified that it is okay to be used to indicate whether a person is on a fatter side or on a non-fatter side, right? So this become my dependent variable, and body mass plus body mass index, it can be through my literature review, through my literature review, body mass index can be influenced by physical activity and diet, okay? And then how do I make physical activity and diet measurable? Again, so they are measurable in the indices like physical activity level based on the GPAC, Global Physical Activity Questionnaire. It is a questionnaire recognized global that physical activity level can be measured through workplace, like you travel to work, that is a physical activity. You travel for leisure, physical activity for leisure, okay, the things that you do for like gym or recreational activities, and etc. etc. So there are levels to it. Now, diet quality, there are diet can be measured through a lot of ways also, and the one that I chose is the quality of the diet of a person. So from my literature review, this is a very small construct that I have constructed. So BMI is the end of the thing, the ultimate outcome that I want to know, right? So this is my dependent variable, and based on my literature review, BMI can be influenced by physical activity level and diet quality. And therefore, what we understand from this is that physical activity level and diet quality can influence a person's BMI. Okay? So when you do literature review, when you read, try to draw out graphics like this. I understand that you also have to like copy paste out the results of people's paper, but in order for you yourself to understand what variable, which variables that you want to include and exclude from your construct, and how are you going to measure each and every one of your variable, okay? Not one variable, I mean, it should not be not measurable, right? Now, so I would like to know, because at master's or PhD level, we have to be a bit, we have to dig more further, right? So the first slide just now is more like for degree level. It is just a linear regression. You just want to find out whether physical activity and diet quality will it influence BMI. Okay, now at master's and PhD level, we will ask more questions. So these are the research questions that you will write in your thesis, right? So now, I would like to know what causes a person to become a different category of BMI, because as we have seen just now, BMI is not just It's not just, oh, A influence B, but now I want to dig deeper. I want to know what sort of person has underweight, tend to be underweight, tend to be normal, tend to be overweight, tend to be obese, right? Yeah, so now you can see it's a bit more deeper lah, right? And then, so if you look at this picture here, I include old people. So as an example, people who are of higher age level can exert different characteristics, and thus they can have different BMI, right? And for young people, young working adults, probably they work more, so their physical activity for work purposes can be higher, and because they don't have time to cook at home to eat healthier, so they just go and buy takeaway from restaurants, and that probably or they can eat more fast foods because they want to be fast, right? So that these sort of behaviors will influence a young working adult's BMI, right? So that's why I am interested to know the characteristics of old people and young people, and also maybe students, right? So if we only look at age, it'll be a bit biased. So why don't we just lump everything in? Because SEM is able to handle that. So but this should also based on your literature review lah. If you are just interested to look at age, then so be it, just age. If you would like to find out more, so all of these can be your demography, right? So just now I give an example of age, right? So now what if I want to know for male and female, for which type of race? Probably the Malays are skinnier than the Chinese are fatter than the Indians, right? And then working in a certain field, their profession, their income level. So all of these things, how you select these things to put into your framework that you are going to test later will come from where? It comes from your literature review, right? Okay, so just now is if you ask the question of, you ask the question at an individual level, right? Now, because I'm an urban planner, right? I'm in urban and regional planning, so I cannot include, I'm not in a position to include variables that are not within my field. So I would rather be stay within my what I'm supposed to do. So literature review has found out that the environment in which we live in might be a cause or might influence a person's BMI, right? And if you think about it, like for example, if a place has a higher land use access, so meaning that, for example, if you compare town neighborhood A and neighborhood B, neighborhood A probably has like higher accessibility to fast foods, and neighborhood B has lower accessibility to fast foods. So this will influence a person's BMI. This might, at this stage, it might influence a person's BMI. So I put this in my framework, right? So the environment, I found out that not only the built environment can influence a person's BMI, but the food environment also influence a person's BMI. So this comes from literature review. I'm sure there are other types of environment that will influence BMI, like economic environment, and etc. etc. but I'm being selective and I'm only including these into my research, right? So what constitutes the built environment? Like I mentioned just now, the land use access from my literature review, and then the density, land use mix, environmental aesthetics. You know, when an environment is pretty, it might attract people to walk more, and thus physical activity will increase. Right? And the recreational facilities, like for example, if a place has more walking facilities, people might walk more. Okay. And then for food environment, it's the same process. These are derived from your literature review, right? The density of food stores, the access, okay? Now, I only have two environment, meaning that I only have two independent variables that I am selecting to test against whether it will cause an increase or decrease in BMI. However, you can include more, right? At PhD level, probably it is more. It can go up to hundreds of variables. Now, again, every single variable needs to be measurable. So there are three types of measurements here. Okay, number one, I put an example from the density. Okay, so density, I might just measure it using scale. So I have 1 very high, 2 high, 3 medium, 4 low, and 5 very low. So the respondents, when they answer the question of density, they will only choose one. So do you, for example, the question, do you live, the housing density of your area, of your neighborhood, is it very high, medium, low, or very low? So the person will tick. But of course, the enumerators will have to be there to explain what does it mean by very high to very low. Okay, in this case, very low can mean like a bungalow, right? A bungalow in an acre, probably there is only 10 bungalows. But in 10 acres, you can have thousands of units in the form of apartments because it goes up. That's why people who live in apartments and all that will have a higher density than those who live in bungalows. Okay, so this item is being measured in a scale manner. All right. Now, the second type of measurement is like this. You can ask questions. This one is, I think most of the time, most people will just lump questions into their questionnaires, right? So it becomes like this. So this indicate that land use access is reflected or can be quantified by a set of questions like this. So I can do most of my shopping at the local stores. The respondents can answer again using this. I can do most of my shopping at the local stores. Is it very high at your neighborhood? Is it, oh no, not very high lah. Maybe it's agreement, extremely agree, agree, neutral, it can be disagree and extremely disagree. So from the list of questions, which is categorical, it can become ordinal later on, which is scale, right? And then the third type of measurement is this type. So this one is categorical, okay? So supermarkets, maybe if you measure it using how many supermarkets are there within like 5-kilometer radius from your house. So that person will write maybe 3 grocery stores, maybe there are 10 non-fast food, maybe there are 20, 30, and 5. So when they answer like that, it becomes numerical. It becomes continuous. Okay, so you have to understand how are you going to measure each and every one of your variables. Okay, so once you have all these, we go a level deeper. Just now, it is only direct relationship. It means that built environment is directly quantified by density, land use maintenance, and land use access and stuff. And built environment has a direct causal effect on BMI. Okay, so these are direct relationship. Now for PhD level, okay, at masters you might stop at this level lah, okay, but at PhD level, probably you want to go a bit more deeper. Okay, you want to explore more in a more focused way. You can scope down your research. So after reading more literature review, you found special discoveries. You found that a decrease in land use mix can cause a decrease in food store availability. I mean, this is pretty normal, because if a place has low land use mix, it can mean that the place maybe only have residential plus commercial. So there is only 2 types of mix, right? Higher mix means that it has a housing, it has recreational area, it has commercial, it has industrial, it has agriculture, so everything in there. So that one will have a higher land use mix, right? So in urban areas, we do have a higher land use mix, yeah, because we have facilities some more, right? So when a place only have like probably housing only, don't even have commercial, so it will cause food store availability to be low as well. If a place only has houses, it is logical if the place do not have grocery store, do not have supermarkets, do not have fast food restaurants even. So this finding from past literature review does make sense, and therefore this relationship might influence BMI. I mean, according to the literature review lah. Okay, this causal factor might influence BMI. So how do you translate that into a construct? Land use mix can cause food store availability, and then food store availability and land use mix can cause the changes in BMI. So this is called a mediation relationship. Okay. Now, let's see another example. Right, let me shift this upward. All right. So if you find out something a bit more complicated, so you found out that the decrease in land use mix can cause a decrease in food store availability, and that has been found to influence diet quality, maybe in Italy or in Japan or in Thailand. Okay, and therefore this relationship can influence a person's BMI. So now you add diet quality here. Now it becomes land use mix can cause the decrease or an increase in food store availability, and therefore it will influence diet quality. And this pathway will influence a person's BMI. Okay, and you also have to link the land use mix with diet quality to BMI. Okay, so this is also called a mediation relationship. Okay, so you have to understand when you read your literature review what sort of relationship it is testing and what outcome it produces. Okay, so if you draw it like this, it is easier for you to understand and construct your framework later. All right, let me see. Oh, we have increased participant. Now, next. What if I found more? Okay, this is another example. Yeah, I found some more special and extra discoveries. Okay, same example. I found that an increase in recreational facilities can cause an increase in food store access. So, and therefore, this might influence BMI based on the literature review. Okay, so how do we draw this? Similar as just now, recreational facilities can cause changes in the food store access in a neighborhood, and therefore this relationship will influence BMI. Sometimes this line here, this recreational facilities to BMI, if you do not find it in literature review, you don't have to draw this line. If this line is not here, this will not be a mediation relationship. It will become just a direct relationship from recreational facilities to food store access to BMI, right? This mediation relationship tells us that from recreational facilities, it indicates to us that recreational facilities can cause changes in a person's BMI, and this effect is mediated or can be influenced by the existence or the high or the lows of food store access. Okay, so the effect of recreational facilities on BMI can be mediated by food store access. Okay. Now, similarly as just now, if you found that this relationship has nothing to do with BMI, it's fine also. Okay. It can come from like 2 or 3 literature reviews, and then you construct this pathway yourself. Like you found that one literature review tells you recreational facilities can influence food store access from one literature review. So you draw this line. And then you found another literature review telling you that food store access can cause changes in a person's diet quality. One literature review can also. And then from a separate literature review, I found that recreational facilities can cause changes in a person's diet quality. So I put this line here. And then I'm sure a lot of literature review shows that diet quality can cause changes in a person's BMI. So I draw this line here. Okay. So it is easier for you to track your literature review if you draw it in such a manner. Okay. So I hope it is understandable up to this stage. So that's why every time you read your literature review, it is not just you reading, but you really have to understand, and then you have to, you can be selective. If you feel like, oh, I found that recreational facilities can influence food store access, and food store access can influence BMI, but maybe I'm not interested in looking at food store access. So I will not draw this thing. So this variable, I'll just treat it as it doesn't exist. Yeah, also can. Okay, so you as a researcher, you have to be selective of which variable you put in. All right. Now, more discoveries. Okay. So just now is we found that each of the environmental variables can cause the changes in another environmental variable. Now, what if you also discovered that higher income people tend to live in built environment with X characteristics, while lower income people tend to live in built environment with Y characteristics. So now it has become even more complicated, right? Just now it is only the relationship inside of built environment. Now it is more, okay? Now we have added another dimension to it. Yeah. So this is similar as just now. From literature review, even though you found that higher income people tend to live in maybe bungalows, so lower density places. So bungalows are naturally more expensive, so higher land value, and maybe the bungalows, because it is placed further, like far from each other, so public facilities are therefore further away. So that is the third one, lower public facilities, maybe, right? You found all this relationship. However, you did not necessarily found that you do not necessarily found that higher income people can cause changes in a person's BMI. Or maybe you found literature review saying that. However, because as much as there are literature reviews saying that higher income people tend to have higher BMI, however, you also found that a handful of literature review telling you that higher income people can have a lower BMI than the lower income people. So what you can say about this situation is that the outcome is inconclusive, because it might depend on the country's their diet and their culture, their norms, right? Like probably people in Germany, they walk more, people in Japan, in Singapore, they walk more than Malaysians. So the BMI can be influenced by other factors. However, that person comes from higher income. So you found the relationship to be inconclusive, to be blurry. So you can also write it in, which is why you are trying to test it now, right? Because the discovery is inconclusive. Yeah. So you would like to test the pattern of the built environment of higher income people. So this one is one pattern. And then you would like to see the environment of lower income people. So you have another set of pattern here. So what this is telling you that it has a moderation relationship. This is a moderated testing, moderation testing, right? Because they are multi-group. First group is higher income people, where the pattern, the pathway, the direction, the magnitude of influence could be different. And then for the lower income people, the pattern of the built environment and food environment can be also different. Okay, So once you understand that, you will draw it in such a manner, right? So I'm going to give you another example. What if it is not an individual? What if it is not income? What if it is the built environment itself has more variety? So it is logical to understand that built environment and food environment in urban area is different. And then the built environment and food environment of rural area is different. Okay, so again, this is a moderated relationship. So you will draw one out here. And then to complicate things, you also found past evidence, which is from literature review, that where a person is residing, urban or rural area, it has great influence on a person's, this one is PAL, sorry, physical activity level specifically, and BMI. So you will draw as such. Built environment and food environment is different in different environment, okay, in urban area and rural area, and these two will cause a person's physical activity level to be different between urban and rural area, and therefore this will influence a person's BMI. Okay, right. Okay, so I added to complicate stuff more. So because you're reading a literature review, you can read up to like hundreds of journals. So there will be a lot of situations or findings or outcomes that you found, right? So another example, you discovered that each type of BMI can also influence the environment in which they live in. So just now, we are talking about how physical activity and diet quality can influence a person's BMI. But now, what if you found a literature review that says this relationship is reversed? Like it is a person's BMI is not caused by physical activity level or diet quality, but it is that person's BMI itself that is causing that person's physical activity level to be lower or higher, and that person's diet quality to be lower or higher, right? So another example is people of higher BMI tend to buy houses situated in built and food environments with characteristics A. While people of lower BMI tend to buy houses situated in built and food environments with characteristics B. So, but for now, you don't know what type of food and built environment each BMI likes. So you would like to find out. Okay, so the direction of pathway, it can be reversed. It can be added or reversed. So you draw it as such. So for now, you don't know yet, because just now, earlier, you found out that BMI is caused by built and food environment in this case, right? But right now, you found another literature review saying otherwise, the opposite. So you can draw two lines for each. Okay? Right. So now that we have gathered all of our literature review, and we have made sense, and we have drawn out the pathway, the lines, the direction, okay, which ones are mediated by which one, which ones you would like to find out more using multi-group, which is mediation. So we want to build our framework. But before that, we need to know the difference between the circles and the rectangulars and all the lines in between. All right. Now, if you look at the left-hand side, you can see that there are no difference at all in all the pink circles and the rectangulars, right? Okay, the circles in SEM means latent variable. So what is latent variable? It is something that cannot be measured directly. Like, for example, okay, sustainability of a building. You cannot just simply say, okay, the sustainability of a building cannot be simply measured by doing a questionnaire survey of asking people, do you think this building has high sustainability, low sustainability, very high sustainability, very low sustainability? It is too simple. Yeah, you will not be able to tell anything even if you have gathered like 1,000 respondents or 1,000 data points. Okay. However, sustainability of a building maybe can be through your literature review, it can be indicated by whether it has GBI star rating or not. I'm not sure how much green area it has, how much what sort of smart features it has, and does it promote does it have rain barrels maybe, does it have horizontal vertical planting maybe, right? So all of these little variables once you include these little variables, these are able to quantify or give you an indication whether a building is sustainable or not. So sustainability of a building, which shouldn't be measured directly, is latent variable. While the things that indicate, the things that quantify the latent variable is manifest variable. So all the little things that I mentioned just now, the rain barrels, the vertical planting and all that, those are manifest variable, right? So all these other things, it is only you yourself know. So you yourself have to indicate graphically in your framework as in the right-hand side, right? Like for me, I don't think it is important to differentiate between second order and manifest and all that. So, but I do want to show which ones are the first order latent variables. So graphically, I make the first order latent variable bold and I leave everything else normal. So I will label it, I will just put a legend to it. Okay, so what we can understand from latent and manifest variable is that latent variables cannot be measured in a straightforward manner. So in our case, latent variables are built environment and food environment. Okay, and all the density, the food store access and all that, those are our manifest variables. Okay. Yeah, this one I would like to mention that when you have measurement methods, which are like, so for BMI, for example, you have underweight, 2 normal, 3 overweight, 4 obese, but you do not write the scale of how you get how you gather the data in the framework. Yeah, this one is considered the lowest ranking already, the lowest hierarchy of the information, lowest level of information already, right? So we do not write these measures in the framework. We only write up to the manifest variables. Okay. Now, This one is to show the order, the hierarchy just now, right? So you can see that from all of our literature review, all that just now, right? So BMI is our dependent manifest variable, okay? And BMI can be caused by physical activity level and diet quality, isn't it, just now? So PAL and DQ are our independent manifest variables. They are they can be rectangular if they are straightforwardly measured using high physical activity level, medium, and low. So it can be a rectangular. If physical activity level, like I mentioned just now, has travel for physical activity for workplace, physical activity for leisure purpose, that one, in that situation, physical activity level will become a circle. And then it will have the rectangulars coming out to indicate leisure, workplace, and etc. Okay, but at this stage, I'll just put it as rectangular. When we look at this sort of framework, we understand that this is the lowest ranking already. So BMI, physical activity, and diet quality are directly measured. They do not have any other quantifiable, any other manifest variables to quantify them, right? So when we look at the built environment and food environment, just now we found out that the built environment can be quantified by a lot of other little items, right? So these items are the independent manifest variables at the lower order, right? So we will draw it as such. And then the built environment, because you do not measure built environment straightforwardly, you do not measure it saying you do not have a question in your questionnaire, you do not straightforwardly ask the respondents, do you think your neighborhood area has high, medium, or low built environment quality? Okay, in our case, we do not do that. We indicate built environment using all these other little items, right? Therefore, our built environment and our food environment are circles because they are latent, okay? So these two are our independent first order latent variable, okay? So when the direction of the line is from point A to point B, it means that A causes B, okay? If the line is reversed from B to A, it means that B is quantified by A, all right? This is important when you are testing and when you are writing your hypothesis, okay? Now, next, all right. So after explaining this simplified version, okay, so based on what we have discussed just now, the case scenario that I show, this can be our first draft of rough theoretical framework already. So after all your hard work in your chapter 2, in your literature review, you can draw this thing up as your summary in your literature review. So you found all this relationship lah, yeah. So just now we say that land use mix can cause changes in food store availability, right? And then food store availability can cause changes in a person's diet quality. And then diet quality can cause changes in a person's BMI. See, the line is here. Okay. And then recreational facilities can cause changes in a person's neighborhood food store access. And food store access in literature review show that it can influence a person's diet quality to be up or down. And diet quality can influence a person's BMI. You see, so all these things are called pathways. Okay. Any other things? Yeah. So if you look at this relationship, these three, built environment in literature review is proven to have relation to cause changes in physical activity level, and physical activity level can cause changes in a person's BMI. And literature review also show that built environment can straight away have direct effect on a person's BMI. Can also. So this thing is called what? It's called a mediation relationship, right? So the direct effects of built environment, which is this line, can be mediated by a person's physical activity level, right? What this means is that even when a person is living in an encouraging built environment, meaning that the environment is super good, got 10 gym, has a lot of recreational facilities, has a lot of walking facilities, right? However, if that person himself is what is that word? Okay, I forgot that word. But that person himself or herself do not like to do physical activity. So even when a person is living in an encouraging environment, because of that person's physical activity is still low, the BMI of that person will still be not good lah. Okay, not good as in or maybe overweight or obese. All right, so this is what it means. All right, so here in the relationship between food environment to BMI, this also indicate that diet quality of a person can mediate the relationship between food environment to BMI, right? So this one is another set of mediation relationship. Okay. All these others are called direct effects, right? So land use mix, based on literature review, can directly influence a person's diet quality. Recreational facilities can directly influence a person's diet quality, okay? And these control variables, sometimes if you want, you can put demography here as another latent variable. Okay, here, demography. Or normally people put socio-economy level. Yeah, so based on research, socio-economy can be quantified or can be indicated by education level, by income level, by their affordability level. So if you would like to turn demography into latent variable, and not demography, socio-economic level into latent variable, which is indicated by education, income, and affordability, you can. But if you don't want, also can. Okay, if you don't want to do that, then each of these variables will become rectangular. It will stand on its own. So it will be directly measured. So you do not need to put a demography or socioeconomic level here. Rather, it will become rectangular here, 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 anywhere lah. You put it anywhere, and then you will draw lines to the BMI because ultimately you do want to know what sort of person tend to have what sort of BMI, right? Yeah. But for the sake of the theoretical framework, in my case, I do not put it as one of the main causal factor. I just want to control it. Yeah, I just want to include it. Because why? You see, in social science, we do, it is sort of compulsory to have demography. We do want to know what sort of person has what sort of BMI or has a higher income or lower income, because at the end of the day, whatever outcome we research on, the output of our research is for the betterment of the human. So it is good to put in the human factor in here, right? Okay, now, so just now we gave a situation where you found that the environmental characteristics and also the physical activity and also the diet quality of a person who lives in rural area is different from a person living in urban area. So now you will have two frameworks. Okay, I just draw it like this, but you can just make it into one lah. Okay, this is just to indicate to you that when you are doing testing later, you will have multi-group, 2 groups. All right. Oh, I think we are out of time. Okay, so simplified version, you just put moderators here: residence area, rural, and urban. Okay. Yeah. So from what we have discussed earlier, in building a framework, you list down the variables that you have found from your literature review, okay? And you yourself have to know which one is your dependent and independent variables. Sometimes a dependent variable can be independent variable for a certain relationship, and sometimes an independent variable can be a dependent variable for certain relationships. The relationships are interchangeably if your literature review indicate as such, right? And you have to know where they stand. You have to know which hierarchy, which level they are at, all right? And then you have to understand which variable is actually related to which variable, because if you draw too many lines, SEM can handle all the relationships, but it'll be very, very complicated. So, and for your research also, it is much better for you to focus on your scope of study. If not, if you look at everything, it'll be endless, right? So for masters or PhDs, it is better for you to focus, right? And then figure out the direction of the causal path for each variable set. Yeah, so one variable can cause many other variables to change. So you have to know where to draw the lines and which direction. Like if BMI just now, physical activity and diet quality and BMI, it'll have 4 lines, right? And then determine what you want to test and what you do not want to test. Yeah, so this one is more about focusing to doing your scoping down your study, because like I mentioned just now, if you try to look at everything, it'll be endless. So it is really better for you to scope it down. Okay, so you can write something in your scope of study. Right? If you just want to look at age difference, then just look at age difference. It's fine. Yeah. If you don't want to look at a difference between male and female, it's fine. Yeah, but you have to justify why. Okay, and maybe if you don't want to look at urban and rural area, you just want to look at urban area only. Okay, fine. You write it in your scope of study. You don't need to look at everything, but everything needs to be justifiable and acceptable, supported by your literature review. Okay, so I hope the first part helps, because building the framework is a very important first step before starting anything. Even if you don't want to do until equation modeling till the end, you want to just stop at EFA, exploratory factor analysis, the framework is still important, right? So we can have a 10 minutes break, right? A 10 minutes break. and then we will come back for part 2A, okay? So I will come back now is 11:08. So I will come back at 11:18 or 11:20. All right. Okay.
Hello, Dr. Shima.
Yes, hi.
Yeah, how much break time? Sorry, I was
Oh,
in
no,
some.
10 minutes, 10 minutes. We have one more minute. I am,
Oh,
yeah.
okay,
Yeah, because just
okay.
now we stopped a bit late because I talked too much.
Oh, no, 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 it's okay. Because I'm doing my academic work, so that's why.
It's okay. All right, now it's 11:20 already. I think we can start back.
Okay, okay. Please,
But let me,
please continue and take.
yeah, let me prepare the data
Okay,
for
okay,
the
okay.
trial. Yeah. Okay. Now, yeah, let me continue back here. Share screen. Okay, I believe I'm sharing again now.
Yes, we can see your slide.
Okay, thank you, thank you. Right, so now we go into our second part, okay? The next 60 minutes. So I hope I'm not boring everybody out, right? Now, so part 2A, let's start. Right, so remember this framework just now that we have built through our literature review, and the lines and all that are correct. You have scoped down your variables. You have double checked it with your lecturer, with your supervisor. All right. So this is the final framework that you would like to test. Okay. So before testing, you have to come up with a bunch of hypotheses. Because why? From your literature review, those are all either has been done in the past. So maybe you would like to see the relevance of it now, or maybe those outputs or results are are being done in other countries, and it has not been done in your country yet. Or it can be you adding more variables to the entire framework of what other people have done before, right? But and you would like to test whether it will it is significant or not. All right. So based on many factors, you come up with your own final framework that is justifiable and is novella. Okay. Or maybe if the framework has been, or like the relationships or the outputs, the results of past literature review, past literature has been done in the same country, but maybe you would like to do it just on females. Maybe the past study is done on like general population. So now you would like to scope it down by using the same framework and just to test on females, maybe, or like vulnerable groups, like children. Okay. So, right. So in this case, from the scenario that I showed just now, yeah, the ultimate thing that I want to do is to know what variables will cause a change in a person's BMI, right? Yeah. So from our literature review, we have found a lot of direct effects, right? Remember the direct effects, the built environment to physical activity to BMI, right? So those are direct effects. And indirect effects are the mediation, which the built environment, the relationship between built environment to BMI can be mediated by physical activity level. Okay, and the moderators where it can be maybe you are testing between the BMI of people living in rural area and people living in urban area. Okay, so those are the moderators. And of course, last but not least, the controllers, which is optional. You can put it in as one of the variables, or you can just put it in as a control variable. Okay, meaning that you will not directly, you are not really interested in the control variables. However, it is necessary to include because a person's age, gender, and all that might might cause changes in a person's BMI lah. It's just that it is not the focus of your study. So you keep the control variables in mind, but what you are really interested to know is the effects of the environment and individual level to BMI. Okay. Now, so most of the time, there are a lot of options for you to build your hypotheses. But the question is, you have to ask yourself, do you really want to test it all? As mentioned just now, having a focus, having a justified scope of study is good, right? Like for example, if you look here, if you want to build a hypothesis, all of these lines can be a hypothesis. So imagine how many hypotheses there are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 hypotheses, and those 24 hypotheses are just on direct effects. So how about the hypothesis for indirect effects? So the relationship between built environment with BMI is mediated by physical activity level, one hypothesis. And then the relationship between food environment and BMI is mediated by diet quality, hypothesis number 2, and so on and so forth. So just now we have this one here, and then we have this recreational facilities here. So if you write it out, there will be like probably, it can go up to hundreds of hypotheses. That's why you have to scope it down, right? I mean, if you are hardworking, you want to do everything, then it's fine. Okay, can also, right? No issue. Now, so some simplified hypotheses are, yes, the ones that I mentioned just now, the direct effects, the built environment, the environmental factors, and the individual level factors can cause BMI to vary between individuals. Okay, and then the mediation, yeah, and then also the mediation relationship between the environmental factor themselves with the individual level factor, which is diet quality. Okay, and all while controlling for your age, your gender, your race, your profession, your income level. All right, and the things that I mentioned just now are only direct and indirect effects. You also, if you would like to, you can also write the hypothesis for the moderators. Okay, I mean, if you already write it in your theoretical framework, probably it means that you you want to test it lah. So if you want to test it, then you include into your hypothesis also. So you have another hypothesis for your moderator. So residence area or area of residence can moderate the changes in a person's BMI. Okay, so this is easily understandable, right? So from your framework, you will come up with hypotheses which has okay. So if you have hundreds of null hypotheses, you also will have hundreds of alternative hypotheses, right? So you will have like 200 hypotheses. So for me, I will try to justify to scope it down lah. Just do the things that is the most important, that you feel is the most urgent to solve, and is novel lah. Okay. Now, examples. Okay, examples of hypotheses. So example of hypotheses are the direct effects. So for me, there are two different ways of writing your hypothesis. For me personally, I tend to have the mindset of before anything, okay, before something is proven otherwise, I will deem it as having no relationship or not significant or yeah, just negatively. Yeah. So the null hypothesis, for me, I tend to write it this way. So the built environment has no significant direct effect on physical activity level, which is this line over here, the built environment and the physical activity, this direct line. Yeah, so for null hypothesis, until proven otherwise, I will say no, it has no relationship. Okay, so my alternative hypothesis will be built environment has significant direct effect on physical activity level. Okay, so yeah, you will write out a set of things for your direct effects. All right, now this H1A to H1F, H2AB, H3A to H3C, this one this one is your own formatting lah. You don't need to follow these. Yeah, this one I just write like this for my own understanding. H1s are for the direct effects, H2s are for maybe the moderators or the indirect effects, and H3 is for something else, right? So for H2A, I do moderator first. So residence area, which is this, residence area negatively moderates the effect of built environment, food environment to BMI. Okay, residence area positively moderates the effect of physical activity level, diet quality to BMI. So what does that mean? It means that you don't know yet, rural or urban, but the place where a person is living in, the area of residence of a person, can positively moderate, how to say positively moderate? Okay lah, for example, okay, maybe we don't write residence area, maybe we write, we straight away write urban area. Yeah, we straight away write here, urban area positively moderates the effect of physical activity level. It means people who live in urban area tend to have has a higher physical activity level, and has a better diet quality and therefore has a better BMI level. Yeah, positively. All right. Excuse me. Okay, residence area, maybe you will have two sets. So null hypothesis is urban area negatively moderates effect, and then rural area, urban area positively moderates effect. And then you write another one for rural area, positively moderate, and rural area negatively moderate. So if you write like that, you will have four. You will have a set of four hypotheses just on the effects of urban and rural to build environment to build environment, food environment to BMI. So that is four. And then you will have to write another set if you want. Urban area negatively moderates the physical activity level and the diet quality level of a person. And then rural area positively moderates relationship between positively moderate the effect of physical activity level and diet quality to BMI. So if you duplicate it like that, you will have 4 plus 4, you will have 8 hypotheses just on urban rural on environmental effects, and rural urban just on individual effects on BMI. I should have typed it out here, but okay, it's okay. Improvement next time. Yeah, but I hope you can understand the building of the hypothesis at this stage. Yeah, and then the third one is the one mentioned just now. So physical activity level positively mediates the relationship between built environment and BMI. And then you can have an alternative hypothesis. Physical activity level negatively mediates the relationship between built environment and BMI. So this liner alone actually has two. It has a null hypothesis and an alternate hypothesis just for this relationship. Okay. Yeah. Now, after you have written out all of your hypotheses, now these will guide you on what sort of analysis you can do, because sometimes the hypothesis that you write, I mean, for other research also, it can influence the analytical method that you use. Sometimes maybe you don't want to find significant direct effect. Maybe you want to find is there a correlation? So if correlation, if your data are ordinal, your independent and your dependent variables are ordinal, then that will influence you to use gamma cruscal. Yeah, but in this case, as we are doing SEM, so we write as such, okay, the direct effects. Yeah, so now I will change the interface. We will start to do data screening first. Structural equation modeling is the last stage. The equation modeling itself only takes like a few clicks to do. However, the large chunk of your work is really to prepare the data to make it valid to be used to estimate equation modeling. Okay, now let's do data screening. So I will stop share this PowerPoint. I will go to SPSS. All right, let me new share. SPSS. Show all windows. Okay. Share. Oop. Okay, wait, it is loading. Right. So I hope you are able to see because my screen is a bit, my screen is like ducked up. Okay, I can see it now. Right. So the first step, before we start anything, is to do missing data. Okay, is to check for missing data, right? Why? Because if the data is missing, the software might not be able to run, or your outcome might not be good. Okay, but it depends. If you are okay with having an average number for the missing data, also can. There are ways that you can fill in the missing data yourself by using an average, by looking at the average responses that respondents give. So you input the missing data in the cell yourself, okay? But let's just try to do missing data first. So I tend to do this just using Excel. Oh, so I have to change, share Excel later. Okay, so I control A, I copy everything, I control C. Okay, I copy everything, yeah? Now, I will go to Excel. So if I go to Excel, I'll need to share Excel, right? Or am I sharing my screen? Book Excel, share. Okay, so I'm here in Excel, yeah? So I control V. See, I have everything here. Right? So what do I do is, so how many total case do I have? Okay, I have 403. So these cases, these information, we just pretend that we went to site, we get the data. Oh yeah, I forgot to show the data itself. Yeah, I would like to explain the data a little bit. Where is my SPSS? Let me open my SPSS. Okay, the data set share. Okay, so we are back here. Now, for the data view, I'm sure, I'm not sure whether you know how to input or not, but before you start anything, you go to variable view. Wait, there's a chat. Okay. Yeah, so you go to SPSS. How you input is, like for example, okay, let me recreate race, because I'm scared, I'm afraid some of you might not be familiar with SPSS. So while we're here, let's just start from the very beginning, all right? So how do you input is, example, I put in, for SPSS, the names cannot have space. Okay, you cannot put residence space area, cannot, right? So if you want, you can put something like this. So you see, if I try, I put residence and then I type a space and I type area. You see there's a space here, right? Enter, cannot, right? Variable name contains illegal character, so no, right? I can only put in maybe residence, okay? So when I put in residence, this one is fine. And here, you will want to go to values, right? So residents just now, we have 2, right? So 1 is urban, then we enter. 2 is rural, then I enter, right? So I okay. So here, you see just now you have the 1.00, right? So if I don't want it to be 0.00, I don't want to have the decimal, I just make it disappear. So yeah, now it becomes pretty, okay, 1 and 2, right? So what is this? It can be, it can be nominal, right? Because it's only 2 categories. However, for like the questions just now, like for land use mix, okay, just now the land use mix, right? Maybe I ask a set of questions, the one that we have, I can do most of my shopping here, parking is easily can be found here and all that. So for each question, it'll be too long to type at the name, right? So I label it myself as LMX 1, 2, 3, 4, 5, 6. So I know that this 1 to 6, these 6 variables are quantifying land use mix. Okay, so we know that land use mix has 6 questions, right? And these 6 questions are the respondents can answer using a 4 Likert scale, which is strongly agree to strongly disagree. Okay, yeah. So let me delete this one. There. Okay, so like just now, these are my control variables, right? The age, gender, education, income thing. Oh, sorry. The race, gender, age, education, and income. Okay, these are my control variables. Okay, area is my moderator. All right, see, urban and rural. Okay, and then BMI is my dependent variable. Then the rest are my independent variables. Okay. Yeah, see, we have physical activity level, we have diet quality, we have the density, we have all the whatnot lah. Okay. So you yourself need to take note your data coding. Okay. Now, so just now, okay. So just now, I copy and pasted everything in Excel, right? Yeah, so let's go back to Excel. Yeah, so how do we check for missing data? We go to last, the first. Okay, I'm just gonna do like a very simple thing. So what we can do is, I mean, in SPSS itself can also do lah. Okay, so you are encouraged to explore which method that you like. Okay, there is no one way of doing things, right? So you count blank. So for the range, you can go in front, click this, you shift, you choose everything. Oh, come back here. Okay, enter. 0. What does 0 mean? 0 means that this case has 0 missing values. Okay, so you just pull it down. Oh, there are missing values here. All right. You know, because this data set, I just randomly do myself for the sake of this trial run. So I think later we'll need to like do something to it, but never mind. So however, for this demonstration is working. So clearly, so you see there are 6 empty cells here. So Excel is telling me that this case 307, has 6 missing values. Okay. Ooh, so many missing values. Okay. But for the sake of this demonstration lah. All right. Now I think for the demonstration, I will need to like let me just copy this and put it down. Maybe Control Shift down. Oh no, I cannot do that. It's just here. Control Shift down. So here, copy. I'll just put down here lah. This one is for the sake of our raw data, yeah, for our trial run. Just going to delete it all. Thing, Control Shift down, then we delete. Yeah, all right. So if you check here at the yellow box, everything is 0. Okay. So if there is a 1 or a 6 like just now, actually you can count the number of your questions. You count the number of your questions. If there is more than 10% of missing values, you can delete off that case lah. Okay. Right. So for now, it is fine. So no missing values. So missing values checked. We delete that one because I need to copy everything. Put it back here because put it back here, new share, check the data. Right, we're back here, paste. Let it run. Okay, let me check back just now. I don't think we have missing values anymore. Okay. Right. Well, you can also sort ascending, right? If you do sort ascending, I mean, if you have little amount of variables, you can sort. You can do like sort ascending. So the ones that are missing, like got 0, 0, 0, it'll appear up here. Okay. Sort ascending, see, it will appear up here if there is missing values, right? Now after that, now that we have 0 cases of missing values, you can write it in your thesis as such, okay? So after checking for missing data, 0 cases were found with missing values. Hence, all 403 cases, which in this case we have, are included in the next steps. Okay? Yeah. So step number 1 done. Oh dear, I think we're running out of time. Let me save. Okay. And then for unengaged responses, what is unengaged responses? Unengaged responses is when, okay, like you see this example. Like this person, he just give everything the same thing. Yeah. So, I mean, he or she might be honest. However, he or she can also just simply answer your questionnaire. Yeah, so they don't put a lot of thought and efforts into it, because you see some people, they can give 3 or 4, like there's a variation in their answer, right? However, for this case, this person, like just now, it's all the same, 4, 4, 4, 4, 4, 4, 4, right? So this might be flagged as unengaged response lah. So if you have so many data, how do you cannot possibly check one by one, right? So what you do, so you go back to Excel just now, right? Go back to Excel just now. We check for standard deviation. Okay, standard deviation. So what you do is equals, you put standard deviation RP. Okay, and then you will only take the latent variables only. I forgot to put the labels. Okay, you only take the, how do I do this? Okay, A, B, C, D, F, G, H, I, J, K, L. Okay, after L, everything is latent. Okay. See, this is why it is important for you to differentiate between latent and manifest variables, right? So your density is manifest because you only ask one question and it is measured directly. However, land use mix access, as I mentioned just now, it has 6 questions. So things like land use mix access are latent variables, okay? So L onwards, yeah. A, B, C, D, E, F, G, H, I, J, K, L, M. Okay. So, yeah, standard deviation. So we'll take M onwards, right? Just now? Yeah, correct. Oh dear. Come on. So we'll put, wait a minute. Nope. Put M. Shift. We'll take everything here. Okay, enter. Right, so you see here, we have 1.4. Take it all down till here. Thus. Okay, so when the numbers are like, so with so many decimals, we'll try to, yeah, so it is easier for you to see. So these are standard deviation numbers. Okay, so how do we read this? Yeah, so anything that is under 0.5 or 0.3 can be considered as unengaged responses. Okay, yeah, there are functions in Excel which you can automate to detect the lower than 0. I think it's conditional formatting, and then see cells greater than, less than 0.3. Okay, right. Let's see now. Are there any cells lesser than 0.3? I don't think so. You see, everything is still yellow. Yes, okay. You see the cells that are empty will become red. Yep, so after we check like this, you can write in your PC stat, after checking for unengaged responses, none of the cases has a value of under 0.5, or none of the cases has a value lesser than 0.3. So none of the cases can be considered as unengaged responses. Therefore, none of the variables, none of the cases are deleted. Okay. So again, all 403 cases will go to the next step, right? So we already checked for unengaged responses. Okay, up until this stage. It is because Rosie just now say that you are just starting out, so I'm like showing really step by step, but yeah. Right, now the third step, we will have to do outliers. Okay, so what is outliers? Outliers is you want to see whether there are any oddballs, whether some cases are too different from other people. Okay, like for example, that person answer he or she is only like 10 years old, but then the education is already PhD. I mean, for a genius, it can be logical, but how many geniuses in the world, right? So probably just 1 out of 100,000, or probably just 5 out of 1 million. So those people are called outliers. It's not that it is wrong to be like that. It's just that they are out of the norm. All right. So let's check for outliers. Okay. But you know, if okay, this is like a tips lah, huh? If your questions are all measured on the same scale. Like you see, for me, for all these LMX right through FHA, all my latent variables are measured using, you see, the same values. All right. For cases like this, if you design your questionnaire to be like this, if you design your data collection to be as such, you will not get outliers. Like it is almost impossible for you to get outliers. Okay, so you can try to design your questionnaire like this lah. Okay, just to make your life easier, right? Now, so for Likert scale, most of the time we will not have outliers. However, the outliers might come from these people. Okay, even for race, I don't think we will have outliers lah, because how can we say like a Malay or a Chinese or an Indian is weird, is an oddball, is an outlier, right? As these races are the normal distribution in Malaysia. So in cases like this, maybe race, we don't need to check for outliers. Same goes for gender. Yeah, there are only two types, male and female. So you also don't need to check for outliers for this, okay? However, for age, like I mentioned just now, the age and the education and income, these might have outliers, okay? So let's check. Let's check on that. Running out of time. I don't know if I'm able to get to SEM now. Right. So I will go to Scratch, Legacy Dialog. I'll go to Boxflow. Simple. Summarize and define. Okay, so I will only do for age, education, and income. All right, now, okay. So you see here, it shows that age do not have outliers. Everybody is normal. But however, 95 case, okay, these numbers are case numbers. So 95 and 88 are outliers, okay, for education, right? And then for income, case 309, 329, 341, and all that are outliers. So this is case by case basis. So if you really want to have a look, we can have a look. So case 95 and 88, let's go have a look at their education, okay? 95 and 88. So we'll go check here. Case 95 and 88. 95. Yeah, look at the education, 7. And then 88 is also 7. But all others are like, they are of normal distribution. Why? Because if we look at education, so everybody else fall in the normal, like, the normal range for this set of population. They are secondary school, A-level foundation diploma. There are only probably 2 out of these 403 that has a master's or PhD. So the computer will say that these people are outliers, but this can be an error that you made when you were doing your data collection. So you tend to go ask people who have degree, diploma, and all that, but not PhDs and masters. Yeah, so can you categorize this as an outlier? Probably not. I wouldn't personally. I would just include it, all right? Because I don't know, maybe they might offer some insights to the outcome later. Okay. So after we check for outliers, All right, after we check for outliers, we will go to check for kurtosis. Okay, as we are using Likert scale for all of these things, right? For all of these things. So skewness can be skipped. Skewness is when something is skewed to one side, like an extreme left or extreme right. However, because our answering range are only between 1 and 4, most probably skewness will not happen lah. So you can write in your thesis as well as such, that you will not that the skewness test will be skipped because it might not appear in your data set due to you using a 4-point Likert scale. All right. However, for kurtosis, we do want to check. Okay, so what we do is can go to analyze, go to descriptive, frequencies. Okay, then you input everything, right? So I'm just going to Control A, put everything, but ID you don't need. Yeah, ID you don't need to input, right? Then you go to statistics. What you want is kurtosis. See here, it's here, right? So you continue. Right. So when you have this, you can see all these things, right? The PQ, DQ, each and every one of the variable will be here. So you copy this, right? Go back to the Excel, to the second sheet, paste. Okay. And then same as just now, okay, the standard error we don't need actually. So let's get it out of the way, delete it. For this line, yeah, conditional formatting. So any value greater than or less than 1, okay, 1 or 2 can be categorized as being curtailed. I can already see a few being curtailed, but never mind. This one is just an imaginary data anyway. So rule greater than. So we're gonna put 2. So we're okay. See, we already have a few. And then less than -2. So 2 and -2, all right? So let's just delete off the ones that have no problem. Delete. Anything else? Yeah, behind all okay. See all these, yeah, we do not have kurtosis problem because these are the Likert scale. So we delete. Let's just have a look at this. All right, so you can see that gender, it's borderline curtailed, probably because the enumerator, he or she just approach a certain gender. That can happen. But however, borderline is fine actually. This borderline is also fine. This one is like a scale. So this, so this is probably fine. So we delete, and then this one we can delete. So the only problematic, not really problematic, extremely curtailed variables are this area, income, BMI, physical activity, and diet quality. These are normal because income, BMI, physical activity, and diet quality of a person can vary, right? Like for me, if I do a lot of physical activity, the next person who I go lunch with probably hasn't even gone jogging for like the past 5 years, right? So it's fine. This area is also explainable because we assume that we assume that we pretend that we are doing the data collection based on using online survey. So if we do online survey, rural areas it might not reach rural areas. So most of the people who answer this questionnaire are of urban areas. Okay, so it is logical for area to be curtailed, right? So what do we do about this kurtosis? We don't do anything about it. We only take note that these things are curtailed, and we see whether these variables will influence the outcome or not. But BMI is here, so it's fine. Yeah, it is just for checking, right? It's good to check. However, we don't really delete or not delete variables due to kurtosis. Okay, if there is skewness, I believe we have to do some log reg thing. Yeah, but yeah, that one is another class lah. Okay, right. Let's see now. Now, after we check for the missing data, unengaged responses, and outliers, sometimes a researcher can include or exclude cases. All right. So sometimes from 403, you can only you are left with maybe 400, or you are left with maybe 385, right? So you will write that in your thesis lah. Okay. Now let's go to EFA. So when you have latent variables just now, you want to know whether true or not these 6 questions can quantify land use mix. Okay, and how well do these variables be estimated together? Okay, how well are their friendship? Something like that lah. Okay, so what do we do? Go to analyze, dimension reduction factor. Okay, and then we will only do on those with a lot of questions. Okay, we will only do those for latent variables, and that's why race, gender, age, area, education, income, BMI, PAL, DQ, density we will not include. We will only look at LMX 1, 2, 3, 4, 5, 6, all these things. Yeah, let me take it all. Okay, let me just no. Right. Okay, put it in first. All right. Put it in first. Okay, now that we have put everything in, all the latent variables in, so we'll go to descriptive. Yeah, we'll take reproduce, and we do want to know KMO and Butler's test, so we'll continue. And extraction, see, there are many types of extraction methods, but I like to use maximum likelihood. You can use another famous way of extraction is PCA, but you have to justify yourself why you're using which rotation method. Okay, which extraction method. Now, fixed number, yeah, I don't want to have a fixed number. However, you can have a fixed number if you want, but no, I want the computer to do it for me. All right, so I continue. Rotation, okay, I use Promax rotation. All right, okay, continue. And then options, I want it to be sorted by size, and I want to suppress small coefficient. So 0.1 is just too small, huh? So normally we take 0.3, right? So, okay, later, continue, okay? After everything done, now we okay. Right, So with this, you can see that our KMO, anything above 0.7 is good. All right. So 8.6, 0.8, let me make it bigger. 0.866 is good. All right. Now for the communalities, we do not want anything less than 0.3. So you can see here, RF2 is 0.03, RF4. So this is also kind of my first time of using this raw data. So we will encounter a lot of problems. So let me write down RF2. Then we have RF4. Right? So anything else that is below 0.3, let me see. Yep, we have this LMX4. Okay. Yeah, so we have three variables that has commonalities problem, and the computer has given us 5 factors with a cumulative of 61%. It means that these 5 factors explains 61% of the outcome that we want. Okay. Above 60% is already good lah, is acceptable lah. A higher number is more desirable. Now we don't look at the factor. However, okay, for this thing, if you look at this large table, so below here, it is good to have a 5% actually. So, all right, right now it is quite acceptable. The pattern matrix is the one that we want to see. Okay, so if you look at here, anything more than 0.7 is best. But okay lah, 0.6 also can lah. But 0.3, okay lah. Anything above 0.3, if your expectation is not that high. I mean, you see RF2, just now RF2 is has commonalities problem, right? So it doesn't even appear anywhere. It means that RF2 is not compatible with any one of it. Meaning that your question, this RF2 question in your questionnaire is not a good question. Okay. So, right, let's just go and delete, take out RF2, RF4, and LMX4. Right, so we go back to dimension reduction, factor, let's go find it. We take out RF2, take it out. We take out RF4, take it out. Take out LMX4, we take it out. If you are doing it by yourself later on, you should take it out one by one lah. Right now, because we're rushing for time, so I'm just gonna take it out all at once, and then we'll click OK, and we'll see again. 0.866, not much difference from just now. However, it is still a good number. Now, let's see the commonalities. So anything else that is below 0.3? Yeah, none. However, we should take a look out on LMX6. This one is borderline. Okay, borderline. You can decide whether to take it out or not lah. Right, but let's have a look. Okay, it is still 5 factors. Now the cumulative has increased to 67%, increased by a little bit lah. Okay, and then we'll have a look here. 4%. Okay, it is better. It is better. Now the pattern matrix. When you look at the pattern matrix, it is not desirable to have a cross-loading like this. It is not desirable to have a negative loading and also cross-loading like this. So I personally would take out LMX6. Okay, wait, I see some chats here. Data is visible, not the result. You can see the result. Wait, Oh, I forgot to, oh my God, I'm so sorry. I need to share. I have been talking by myself all this while. Right, is it visible now? I am so sorry. I've been talking by myself.
It's okay, Dr. Shima, the responsibility of your audience, because if they can't see, they should talk.
No, yeah. Oh my God. Yeah, they did write it in the chat. I just saw it now. I'm so sorry. Okay, it's okay. This is a very simple thing. Let me do it again one more time. Oh no, it's visible. Okay, it's okay. It's okay, guys. Let's try and do it again. 5 minutes, okay? 5 minutes, yeah. Hey, but is this this thing that I'm showing you all know already, or you want me to explain again? Because some people already know EFA and all that, right? Wait, oh. Cannot see where is the chat. Oh, okay lah, never mind. Right. Okay, let me do it again. So analyze, right? You go to analyze, like just now, dimension reduction. Oh no, actually, let me just go to the output. Let me just go to the output. New share output. Right. You see, just now, I did a frequency test, right? Okay, wait. So everybody can see the data now? Can everybody see the data? Okay. Thank you, Fazila. Now, so the frequency is the one just now that I did in Excel to check for kurtosis, right? Now, to save time, I will not click everything again, but rather just look at the output. Like you see, initially the KMO, the Butler's test, it shows 0.866 here, right? Which is good. Okay, anything more than 0.7 is good. All right, and you see the significance of the Butler's test, it is significant. So it means that it is good. Okay, and you should report these things in your thesis. Okay, now for the second column table, communalities. So you see communalities means that something is too similar to the other. For your questionnaire, every question should be special. It shouldn't sound similar. It shouldn't be measuring the same thing. If not, that question is redundant. Okay, it will only clog your data set, right? So you have to be selective, right? So communalities, anything that is less than 0.3 lah, okay, less than 0.2 lah, okay, in the initial stage, we will take out. So just now, I found that RF2, you see here, RF2 is 0.03, which is very, very low. Okay. And then RF4 is 0.156. That is very low as well. And then LMX4 is 0.2. So everything is below 0.3. So it is not good, right? But sometimes if the result behind like the total variance explained is okay, you might want to consider retaining it, but we'll see, right? So you see here, the total variance explained table, you can see that 5 factors have been successfully extracted, and then cumulatively, these 5 factors explain 61.6% of the entire of the thing that you want to find out lah, okay? Right, and then we don't look at the factor matrix. Okay, you look here. If you look here now, oops, yeah, here. The residuals, they are 5% non-redundant residuals. Okay, anything less than 5% is desirable. So if this is like 14% or like 50%, it means that you have a lot of redundancy in your questionnaire. That is not good lah. Okay, better to have 5% or lesser. Okay, here. So this is another checkpoint. Now, pattern matrix is the thing that we want to see. So you can see here 5 factors. So factor number 1, everything is okay. Factor 1, 2, 3, 4, 5, everything loaded pretty nicely, except for things that you want to see is if they are negative loadings or they are cross loadings, right? You see here, LMX5 has cross loading and LMX6 has cross loadings. RF2 did not even load anywhere. RF4 also did not load anywhere. So it means that we will eliminate variables. Yeah. So, you know, sometimes you will feel like, oh, I have already spent like 1 year collecting data. If I delete it now, it's like, I don't feel good about it, but you have to, okay? You have to eliminate it because the data is useless at this point, right? So just now, I took out those that have commonalities issues like RF2, you see I took out already, RF4 and LMX4. I took out already, right? And then I run the system again. It's this one, sorry. So this one, right? So I run the system again. Yeah, so none of it is below 0.3, which is good. However, LMX6, we have to like have a lookout for it lah, all right, because it is borderline 0.357, right? So after checking for everything, maybe I would like to take out LMX6. Okay, however, the total variance explained, it is still 5, and this total variance explained is has increased. Percentage has increased after you take out those that have commonalities issue, and from 5%, redundancy has come down to 4%, which is even better. Now, LMX5 has cross-loading, LMX6 has cross-loading. Okay lah, let's just, for the sake of the demonstration, let's just take out those two lah, huh? Let me write it down, LMX5 and LMX6. Right. Okay. Right, so wait, let me go back to the data set. We analyze, we dimension reduction, go to factor, and then which ones are we to take out? We take out LMX5 and LMX6. Right, then we okay again. Right, so after we okay, so after we okay, you see, KMO has gone down a little bit, but it's still acceptable, 0.62, 862, significant. See, everything is good now. Commonalities is good, pass. Yeah, percentage, cumulative percentage has increased by 2%, good. Yeah, this is borderline 70%, so this is getting better. When we look at here, redundancy has gone down to 3% from 5%. Everything is looking better now. Look at the pattern matrix. It is really, really, really better. Okay, so what you have to report in your thesis for this is, first is the KMO and Butler's test. Okay, so it passed the KMO and Butler's test where KMO is 0.862. It is significant, and then none of it has commonalities problem, whereby none of the amount. Do we need to do anything for RF1 and RF3? No. RF1 and RF3 at this stage is eliminated already. That's why I mentioned just now, even though you have been collecting your data, say like you have 1,000 respondents, and you feel, very sad lah, the question of RF1 and RF3, I have to eliminate. People have answered it, I have to answer already, but There is no choice. You have to eliminate. Okay, because those questions does not help you in answering your research question. Okay, yeah. So you do not need to do. Oh wait, RF1 and RF3. Oh, you mean these two, RF1 and RF3? No. RF1 and RF3 are fine. They are fine as is. They are 0.7 and 0.8. They don't have commonalities issue, right? Sorry. I was talking about the 2 and 4 just now. Okay, right. So, yeah, and then you mentioned that the total variance explained, 5 factors have been extracted. Okay, five factors were extracted with a cumulative percentage of 69.96, or you want to just round it up with a cumulative of 70%. Okay, so because the ideal total variance explained should be above 60%, therefore this test this data set is a good data set. Okay, and then you can also report this redundancy is only 3%, which is less than the acceptable 5%. So this is also good. And this is the most important thing that you report. So based on the pattern matrix, okay, you list down all these things. You can actually just copy paste this for your thesis, but you have to label it okay? Factor 1, 2, 3, 4, 5. You will give it a name yourself. A factor can be made with only 2 questions, but it is not desirable. That's why most of the time people will put like maybe 5 to 10 questions for each of the latent variables. Because after all this reduction and exploration, you might be left with only 3, 4, or 2 questions to quantify your latent variable. That is not really desirable. Even in structural equation modeling later, it is not that reliable. It is not desirable. For SEM, for each of the latent variable, it is better to have more than 3, at least 3 items to quantify a single latent variable. Okay. So in this case, this is just for demonstration. So you report as such okay? So factor 1, you will give it a name. If you do not have a name yet, you give it a name. Yeah, so for us, we already know. Factor 1 is food store accessibility. Question 1 to question 8, loaded nicely. So you can report that as expected. The questions under, or the items under food store accessibility loaded under under the same factor with the loadings of then you write down with the loadings of 0.626 to 0.921, something like that. Okay. Right, so I hope it helps. I think our EFA is done here. Okay, so after EFA, what do we do? 12:30 already. Okay lah. I think we have another break. Our break is supposed to be 1 hour, but we are left with half an hour only. So sorry. So we have a half an hour break, and then we will continue with reliability test, and then with CFA, and then SEM. Okay. I'm so sorry for talking too much. We might not have enough time to finish everything, but yeah, we will come back at 1 p.m. Okay, 1 p.m. Yeah. Thank you.
Dr. Hashimah, 1 p.m. is mean
1 p.m.
in Malaysia time 1 p.m. right?
Yes, sorry. Yeah, Malaysia time 1 p.m. In Thailand time.
But because if you back 1 p.m.
yeah,
that time we will have 1 hour break. Could you?
The 1 hour break is compulsory?
It's not compulsory, but our time actually 4 hours.
Okay, okay.
Lunch time.
Okay, sure. Sorry. Okay,
So could you please continue more 20 minutes, then we'll give break, and then we'll back, in
can. Sure,
2
sure.
p.m. in Palestine time and 1 p.m. in Thailand time.
Okay, okay. Sorry. All right. I thought we run out of time. It's good that we have more time. Okay, so I can continue. Now, for the next step, it is reliability test. It is the last test before we move into.
We can see your slide.
Oh, yeah. I have not shared my slide yet. Wait, let me share. Okay. All right. So the last step to before we do our CFA, which is a confirmatory factor analysis, we will do reliability test. Okay. Right. Oh yeah, I forgot to mention. Wait, let me show back the output just now. Share the output. Right. Okay. Because just now I did mention about adequacy and all that, right, in the slide. So I thought I shouldn't just say you report this and that. So the proper way to say it is for adequacy. For adequacy of data, adequacy is shown through the KMO. All right. So adequacy is shown through KMO, commonalities, and total variance explained. Right. So you report all this 0.86, 0.0, all this not less than 0.3, and then the percentage. All right. So these three are for adequacy of data. Okay. Now, second thing, I also mentioned validity, right? So we have two types of validity. Okay. The first one is conversion validity. Okay, so conversion validity is dependent on sample size. For a sample size of above 300, any variables loading under each factor, which is this one, pattern matrix, any variables loading under each factor that is more than 3 is acceptable. So we have 403. We have 403 data set. So all these are above 0.3. So conversion validity is achieved. Okay. However, 0.3 is the minimum, very minimum. So it is better for you to take 0.5 if possible. Okay, because better if your data set is above 0.5, just say it is above 0.5. So it gives more confidence to people of your data set, right? So you can say that all of the variables loading are above, let's see now, yeah, above 0.6. It is at least 0.6. So it is good. It has achieved conversion validity. Everything has passed. Even the lowest loading is 0.661, 0.626. Okay, right? Now, the second validity is discriminant validity. Okay. Discriminant validity, how are you going to ascertain that? Is number one, you do not have cross-loading. Yeah, so just now, the ones that have cross-loadings, we delete. Okay, we delete it off. So right now, we do not have any cross loadings. Okay. So discriminant validity is achieved. Right. Secondly, at the factor correlation matrix, this one, right? Even though this thing is haywire and all that, but never mind it. I don't think you need to show this one in your thesis. This one is more important, right? But this one, what you need to report is there should not be anything, it is haywire. The factor matrix should not have anything more than 0.7. But never mind, because this data set is like, I just randomly do it myself just for the sake of demonstration. But factor matrix should not have anything more than 0.7. Okay. What happens if we have all these more than 0.7? It means that there is problem lah with the way you collect your data. All right. You see this 0.5, 0.5, 0.3, 0.6, 0.5. These are acceptable. However, these, they are 0.7, 0.7, 0.7, 0.8, 0.6. No, 0.6 is fine. Yeah, these 0.7 things. These have problems. Okay. But sometimes, you know, just to make life a bit more simpler, maybe if your passing assumptions for validity is only convergent and only discriminant validity using the no cross-loading assumption, no cross-loading requirement also can. So you don't need to mention that the factor matrix you have like more than like a few items that is more than 0.7 lah and all that. Okay, if not, you have to go back and fix it. Okay, if it looks nice here already, then just accept it lah. Okay. Now, for a tips here. Okay. Oh, sorry. It is not the factor matrix. No wonder it looks haywire. It's actually the factor correlation matrix. Didn't realize there's one more down here. All right, for the factor correlation matrix, anything more than 0.7 is not desirable. Okay. The data set that I just randomly did is actually looking pretty good. Nothing is more than 0.7 here. Wow, this is pretty good. Okay. Now, so yes, you can write your discriminant validity, no cross-loading, and none of the values are above 0.7. So the discriminant validity is achieved. Right? Now, there is a tip here. If we square the values of in this table, we are able to tell the percentage of correlation between each factor, right? What does that mean? For example, factor 1 and factor 2. Yeah, no. Let's take a positive number, this one. Factor 1 and factor 3. Okay, it is 0.003. So if we square it, let me try to square it. If I take 0.003, I times 0.003. Okay, it is 0.00009. Okay, it doesn't matter, but wait, then I have to 100. Okay, it is 0.00009. What it tells us is that factor 1 and factor 3 are correlated 0.0009%. Means that it is very poorly correlated. Okay. If we take factor 2 and factor 4, we try. All right. If we try this one, try to take 0.043, we times with 0.043 times with 100. So we get 0.185. Yeah, so it means that factor 2 and factor 4 are correlated 0.185%, which is very low. Okay. These are just extra information that if you want to write in your thesis, you can. If you don't write, also fine. All right. Because sometimes our objectives, we want to know the correlation between the latent variables, between the factors. Okay. Yeah. So now for the last step, we will go to reliability. Okay, so for reliability, go to analyze. We will go to scale, go to reliability. Okay. So reliability is the same for race, gender, age, area, and all that. We don't do all that for these. Okay. We only do the reliability for those latent variables. Like this. Yep. And when we do it latent by latent. Okay, we don't do it we don't jumble everything in there, right? So we do it one by one. Okay, so statistics, killer, it's fine. I don't think we need to click anything here. All right, continue. We use alpha model. Here you can also, if you want, you can also go find out what each model or method is suitable for you. However, largely people just use alpha lah. Okay. So okay. So when we click OK, we will go to the output table. Right. So in this output table, I hope I'm in output. Yeah, I am in output. Okay. You can see that for the 6 items that I included, the Chromebox alpha is 0.85. So I'm sure you all know the acceptable Chromebox alpha value is supposed to be more than 0.7. Okay, so 0.7 is desirable. If you cannot get 0.7, maybe 0.6 is still acceptable lah. Okay, now so you have to do for each and every one. So so it means that for the first set is pass lah. Okay, it is reliable. Now let's try to do second one. Control A, put it back. Now we try this one. Q4. Did we delete anything? No, I don't think so. Yeah. Let's try a second one. Same alpha. Ding. Let's see now. Higher. So for these 8 items, it is the Chromebox alpha is 0.937. So it means that these 8 questions, they work together really nicely. They are all special enough to measure a different thing, but they all quantify the same thing. So this is very desirable. Okay, 0.937. So you do for all of the latent variables only. Okay. Yeah, so I'm not going to do maybe I'm going to do another one. This one only 3. Okay, let's do the 2. So just now we eliminated 2 and 4, right, from RF. So we're only left with RF1 and RF3. Okay, so if up there, the stage just now, you eliminate it already. So when you are doing reliability tests, you shouldn't put it in again lah. Okay, so you just take the ones that already passed the validity test, you put here, you okay. Right. So for these two items, they work well together. They are individual enough to work well together. And it has a Cronbach's alpha value of 0.88. Okay, very good, very good. All right. Anything else? Okay, now, so after you have done the reliability, you report this table, all these little tables, this one, this one, this one, okay. The next step, we can go into CFA. Right. So sometimes at master's level, you can stop right here. When you stop here, some people, when they come up with their own questionnaire, maybe the questions that they come up with are something out of their own heads. It is not like it has not been tested for its reliability and validity before. So those kind of research, they will have to go through this EFA test until reliability. So you can write a paper up until this stage. You can write a paper on reliability and validity of some variables or of questionnaire. Yeah, so this is how people establish reliability and validity of questionnaire. So maybe some other people, like if I were to establish reliability and validity of questionnaire X in the context of Malaysia, you in Thailand or in China or in Italy or in Japan, you can take this questionnaire of mine, which has been tested for its reliability and validity in Malaysia, and you take the same items, you do it in your own country. Okay, let's just say Japan or Singapore lah. Okay, we do it in Singapore. And then you can write a paper on it and establish the reliability and validity of using this questionnaire X in the context of Singapore. Okay, yeah. So, I mean, yeah, it is quite an easy way to write a paper lah, because even the steps are simple. And now that you know the qualifying requirements, I'm sure you are all able to write papers lah out of it. All right. Okay. Now, okay. Now that I have this pattern matrix, right? I would like to, wait, let me see now. I would like to just do this. Wait, I need to save the data first. So every time if you do something from SPSS to whatever software that you use for your SEM, you should save your you should click save in your SPSS first. Okay, so I've clicked save. You see, I double check, click save here. Now I will go to, let me go to Amos. Let me open an Amos here. Okay, for me, I'm using Amos. Okay, there are PLS, there are other softwares that you can use. Okay, but I use Amos because it is more accessible for me, and I've been using it for a while now, so I am more comfortable lah. Okay, now screen sharing. Let me share this thing. Okay. Right, I hope everybody can see Amos. Right, so So this thing is it's empty, right? You can change the size, the paper size, and all that in here. You can go explore yourself. However, because I think okay, you can go explore yourself. Yeah. Now, you see, all these are my past files, but I don't want. I want to open a new file. Okay, new. Okay, it is still there. Never mind. Wait, I think I need to save out the data in. Let me wait. Let me take it out first. Put it in another file so it can be prettier. That's later. You want to proceed? We are yes. Please move this window away from the shared application. No. Okay. So for data trial, let me save it in another file so it is prettier. I'm gonna close my Excel, don't save. Okay. My screen sharing is paused. Okay, wait. Okay, let me create a new file. New file. I'll name it. I'll name it data trial 2023. Okay, then I'll go take the data trial and the step tool package, copy, put it into the file. Okay, now let's build it. New share. All right, I'm back here. Okay. I will, when you open this, you will need to click this, select data. Okay, so you select the data. You see now this interface is empty, right? It is empty. So you go to file name. My God, so many things, right? So just now I created a new file, right? It's here. So you see, if you have a lot of data set, you have like, oh, this project lah, that project lah, okay? You choose the one data set that you want to analyze, all right? So for me, there is only one. So choose it, data trial, see, it's here. Now, you don't need to do anything else, just click OK. All right. Screen sharing is paused. Okay. Right. So when I click that just now, it means that the data set has been loaded from SPSS to Amos. Okay. Right. Now, what do I do? Right. If you click this, not sure whether you guys are familiar with this interface or not, but just like Excel and SPSS just now, I'll show you like really like a step-by-step lah. Right, so you see, you already have all your variables from SPSS here, right? If you want to build it, you can build it manually, you can automate it, okay? Now, I'm going to show you the manual way of doing it first, right? And later, you explore yourself how to automate it or how to make it prettier, okay? Now, I'm going to just do a full model first. Remember just now, BMI is our dependent variable, right? So BMI, I'm going to put it here, okay? And then BMI is influenced by physical activity level. It is influenced by DQ, diet quality, right? Now, you yourself have to know. You have built environment. Why latent variables are not here? Because only manifest variables will appear as your variables here lah, okay? So you have to draw yourself the circle ones like this. Okay, I'll just show you two ways lah. One is this. Let me try this one. Ah, okay, can. Okay, right. So two ways, okay? Now let me delete this one first. I'll show you the first way first. All right. So this way is a manual way. Yeah, if you want to delete something, Amos is quite rigid. If you want to delete something, you can only click the delete and then you delete. If not, now see, I cannot delete anything, right? So I take back the PAL, I put here, right? Now this round thing doesn't have anything here. So I would like to input a name for it. So what's the variable name? It is build environment, isn't it? So similarly as SPSS, try not to have space. Okay, don't have space. I haven't tried if we put space, but just to avoid problems, try not to have space lah. Okay, and then yeah, see the environment is here. Now, if you want to copy this thing, you want everything to be the same size. Okay, if you want to change size, see, you cannot click anything. You have to click this thing. Change the shape of the object. Shape, what is this one? Yeah, okay, and I put it nicely like this, right? So if I were to take this one and I do it myself, it'll be different size. So not nice. So maybe I want to copy. So I click this copy thing, copy, and I put it here, right? Because the second one is food environment, right? So I click it again, double click. So I change it to food environment. Okay. All right, done. Okay. Same, right? Like just now. I need to move this one down a bit. Okay. Now, next, what do we do? Oh, okay. So this is one way to do it. Another way is, let me delete off this. Yeah. Another way is this. You take this thing, click here, and then you just click inside here. 1 click, 2 click, 3 click, 4 click. How many clicks? It depends on how many manifest variables you have. Let's say this thing, like your built environment is, no. Let's say your LMX is 1, 2, 3, 4, 5, 6, 6. So this thing, you will write, alamak, okay. Let's say it is land use mix. All right. Like say, this one is just for demonstration sake. So land use mix, you have 1, you have 2, you have 3, 4, 5, 6. Okay, we have all this. Now, if you want to change the direction, just do it like that. Okay, so this is one way, right? No, I don't want to rotate it anymore. Right, so let's move this thing, the environment. And then, yeah, I think I'm going to just copy the environment and do it food environment. Food environment, right. I'm just going to show you a very messy one. Later on, I will do like a pretty one. Okay, so, wow. Now I have to.
And Dr. Shima, do you
Yes.
mind? Can I say something? Now,
Yeah.
if you want, we can go break for 1 hour and we'll back in Malaysian time too.
Oh, yeah, sure, can.
Okay. And in Thailand time, we'll back 1 p.m.
Okay, so I will come back at 2 and we will
Yes.
continue. Okay, sorry, I just talked too much.
Thank you. Thank you.
Right, so let me stop sharing. So I will come back in 1 hour's time, okay? Bye, everyone. Okay, hi everybody. I am back now. Yeah, let me see. So I did some. I built the data. I built the construct already just now. Let me share screen. Okay, but before anything, I would also like to mention that if you have if you have continuous data, like say for example your age. But everybody is in, right? Okay, 2 p.m. So we shall start. Yeah, we shall start now. So if you have continuous data, meaning that your age is you collect the data using you just ask the person to write in their age. Maybe the answer that you will get is like 34 years old, 56 years old, 12 years old, maybe. So those are continuous data, right? It ranges because age, right? It ranges from 1 to maybe 100 or 120. So the numbers, there are a lot of numbers, right? So to make your life easier to do SEM, better for you to change your or turn your continuous data into categorical, meaning that those people who are aged, if that person were to write their answer 19, so you will categorize it as 1. If that person answer their questionnaire saying that they are 34 years old, then you will categorize that person as 3. Okay, so you categorize the categories of the age of the person yourself. Okay, right? So again, in SEM, it is better for you to have a simplified range of answer. So continuous data like age or like temperature, 30 Celsius, 40 Celsius and all that, it is better to categorize it, okay, into like 1 to 5 or 1 to 6 or even 1 to 10, but just make it categorical so that it is easier for you, okay? So that is one. Now, the second one, I forgot to mention that when we are building our model in, let me open this that I have saved. When we open our data in, yeah, this one is the one that I built just now. I hope you can see it. I hope I'm opening the correct thing. New share. Yeah, okay. So I did this just now. So remember why we go through all the EFA, the reliability test in SPSS. Okay, it is for you to be selective. So as I mentioned just now, whatever redundant questions, whatever questions that are not unique enough, questions that do not jive well with other questions in order to quantify certain latent variables, it should be eliminated. So from there, you are already doing your first level of filtering and first level of deleting the variables, right? So when we build our framework or our construct in Amos or in like in your equation model, you should already eliminate those that has been eliminated during EFA. Okay, so as you can see here, the recreational facilities, we are only left with RF1 and RF3 because 2 and 4 we have already deleted it back in the EFA stage. That is why every single stage that you go through, whatever variables that you eliminate or you add in or you covariate or you correlate, you have to write down and record in your thesis. Yeah. So as to, it is like a note lah for yourself also, okay? And also for the reader to understand why at a certain stage, certain variables are not there anymore, okay? Now, I have shown the ways to build a model just now, like all the little functions of all these things. So yeah, so you see rectangular, the round and all that. This one I show already. Okay, the lines. Okay, so these lines are important. So based on your theoretical framework that you built just now, you will draw your framework now as how you have drawn during your theoretical framework. Okay, from your literature review. So this is why the framework is an important guideline for you to move forward. Okay, now, first thing I mentioned, second thing I mentioned, oh yeah, the LMX 4, 5, 6 I've eliminated just now, yeah. So 4 should not be here. Let me delete it off. Did we eliminate it? Okay, never mind. Right. So I'm going to save it. Ding. Okay. You see, another tips for you is every stage of the model that you build in your whatever platform that you choose, save. You see, like me, underneath here, one is the full one is the 1A, one is the measurement model, one is the pattern builder, invariance test, C and B. If you do not save it at every stage, sometimes you might regret it, because once you delete off something and then you have run your analysis and all that, you might forget the steps. You might forget which variables did I input or which variable did I eliminate, because you know you are doing research. It is like lab work. You are experimenting. It's just that you are experimenting with variables now. You're not experimenting with like mice, or you're not experimenting with like human blood or things like that. So once you delete off something and you run the analysis and you feel like, maybe I would like to add that thing back, because if I delete it, the result is not that much better anyway. So it will save you some time if you just save the entire thing again and again and again. All right. Now, this full model is a very, very, very rough thing. Yeah. Actually, I wanted to show something like, for example, just now when I show you let me put this thing aside. Okay, maybe put it down here. Yeah. Imagine just now you built this thing. Okay, so let's just look at the built environment cohort yeah, here. So you will have to add this thing, which is error term. Okay, you need to add error term. You don't need to add on the latent variables, but you need to add on the manifest variables. So you just click like that. Okay. Ding, ding, ding. So what are error terms? You see, when we do social science, right, it's not really 1 + 1 = 2. We're not like mathematics. Okay, unless you are doing like really mathematics or like chemical stuff. So you know 1 + 1 = 2. Even then, there will be human errors. There will be like maybe maybe someone else took like 0.2 decimals, you took like 0.4 decimals. So those little things uh, uh, are being addressed in error terms. So you have to put it in, yeah. So those are for like mathematics and chemicals and stuff. But in social science, the error terms can be bigger because like physical activity alone, right? It cannot be fully explained by built environment only. It can be explained by things that we did not put it in this entire framework, like a person's health status, which is not here. Health status may be like uh, di diabetic or not, has heart disease or not, has a history of family illness or not, those kind of things, right? And then maybe a person's behavior preference, uh, yeah, anything. So all of that are addressed in error terms. Okay, so once we have put in the error terms, you see it's all empty, right? Everything needs to have a name in here. So how do we do that? This is only for error terms, okay? For error terms, once you have, if you build your model using manually, you go to plugins, you go to name parameters, and sorry, cancel. Name unobserved variables. Okay, name unobserved variables and click see magic. So Amos will give a number, or rather a name. So all the error terms that you put in here. So you see error 22, error 21. So everything has, all the manifest variables have their own error terms. Okay. Right. Oh, we missed one out. If there is one variable that you miss out, do not have error term, the analysis will not run. So it is important that you double check lah. Okay, so I just saved this one. This is just to introduce you how to draw a graphic on Amos, so that you understand that which one is manifest variables. And oh yeah, lines. Okay, lines is simple. You see, I delete this line. All right, I delete this line. So based on our theoretical model, we did previous literature review did tell us that physical activity and diet can influence BMI. So the direction is from diet quality and physical activity to BMI. Okay, and then as for this land use mix and all these latent variables, it is indicated by, it is quantified by these questions inside of the questionnaire. Okay, yeah, so essentially LMX1, 2, 3, RFY, and RF1, RF3, these are all the questions in your questionnaire. Okay, so that's why really the framework is very, very important. Okay, now that we have gone through that, right, see, because the steps are really long, I have to make notes. Now, there are many preparatory work before we can start testing this model. However, just for the fun of it, okay, if you click this analysis properties, you can analyze already. Calculate estimate. You can analyze already. Okay, but in analysis properties, you can choose what are the things that you want Amos to do for you. Estimation, we are using maximum likelihood, but you can also explore yourself. What are the other things that you can do? Okay, numerical, this one is normal, bias, yeah, how to like output is normal. Wait, bootstrap, okay, or what are bootstraps for? Okay, you can find out yourself. Now, for the output, for this stage, we'll choose minimization history. We'll choose standardized estimates. We'll also choose modification indices. we'll put the threshold to be 20 lah. Okay, modification indices is like your helper. It helps you. It gives you an indication of which one to correlate with which one. Okay, later we will see. All right, and then maybe a correlation, factor weights, covariation, critical ratios. Okay, yep. There is no OK button, just X, right? Okay, now let's try to run. Oh, see, one more. Ding. To add the plugin. Oops. To add the plugin name on our stuff. All right, now save. Cross. Okay, let's see now. What's the problem? More than one variable name, FSA access. Yeah, where? There two? Are there two? Oh yeah, there are two. Okay, because I copy and pasted it. Okay, so this one is availability. See, it is very sensitive, right? Avail. All right. So close it. Then we'll try again. Okay lah. I must say before uncorrelated. It's okay. Just proceed. We'll just try. Okay lah. This set of data, we have not done any assumptions check yet. So you see, there are a lot of like error and all that. Okay, so it'll tell you, but right. So wait, cannot. Okay, so that's why preparatory work before you can build your final equation modeling needs to be done lah. So let's do that now, right? But however, this should be the sort of like a draft or final look lah of the thing. It's just that when you try to analyze it, it won't run because there are a lot of errors in it. So now let's go and have a step-by-step of how you can check for reliability, validity, and all that. Yeah. So you can do. So what we want to do now, yeah, is multicollinearity. Yeah, multicollinearity, homoscedasticity, okay, invariance test, and linearity test. Okay, so for SEM, any variables that are not linear, it will not run. Okay, I'm not sure whether this data set will run or not because I just randomly do out a bunch of numbers for the sake of demonstration. So I am sure there are going to be a lot of problems. Right, but anyhow, let's just go to the step-by-step lah. Okay, now we are back here. You can actually do multicollinearity, linearity test, homoscedasticity in Amos, but I find doing it in SPSS is more simple. So for beginners like yourself, maybe it is also easier lah. Okay, now first one, at the very beginning, we already tested for missing data, unengaged responses, and outliers. Now, we will do a multicollinearity test. Okay, so you go to analyze, we'll go to regression and linear. Okay. Yeah. I already input it during the break. So the dependent will be our ID. Okay. The 1, 2, 3, 4, the case numbers, and then the independent will be everything. All right, because we do want to check everything. right? So now you go to statistics, and oh yeah, I also click already. Yeah, so you will click on model fit, estimates, collinearity diagnostics. Okay, then you click continue. If you want, you can also click boxes of oh, no need lah. Okay, just estimates, model fit, and linearity. If you want to, if you don't want to click estimates and model fit, also can, but okay lah. Just continue. Then we click okay. Yeah, okay. So what we did just now essentially is something like multiple regression. Okay, it's just that for our sake, we name it multicollinearity because we do want to check for collinearity. That's why we check the box of collinearity diagnostic. If you want to do multiple regression, the boxes that you tick just now can be a bit different lah. Okay, now what you are interested in is, you see even ANOVA, oh, it is significant. So meaning that this entire, collinearity diagnostic is significant lah, it can be used. This is the place where, let me see the check. This is data view again. Sorry. Always forgot. Okay, now, can you see the output? Can you see the output? Okay. Right. So now, when you look at regression, you can see now this ANOVA. ANOVA is significant. Okay. So as I mentioned just now, if you are doing multiple regression, you will also get back almost the same boxes. Okay. So these are the things that you will report. I know it is significant and all that, right? And then you will also get your R square. Okay. So this entire thing explains 28% of whatever that you're testing lah. Okay. That's the R square, right? Now, the thing that you are interested in is tolerance and VIF, these two. Okay, you see collinearity statistics, right? So for tolerance, this thing, if you want to report it in your thesis, you have, yeah, thank you, right? You have to, you can copy it out, just copy it out and then paste it in your thesis. Yeah, and then you can even highlight whatever that you think, whatever that you want to report lah, okay? But for collinearity, we will look at tolerance and VIF. So for tolerance, the value should not be less than 0.01, okay? So do we have that problem here at tolerance? No, okay? So what you can report is that most of the values, and not most of the, all of the values, okay, of the variables has a tolerance value of not less than 0.01, and therefore a data set is accepted. Okay, collinearity, first step is pass. Now, second requirement is VIF. So for VIF, none of these values should be more than 10. Okay, now let's see now. Anything more than 10? Okay, thank God, nothing is more than 10. Okay, so this data set that I just do is okay lah, can lah. I'm actually expecting like a lot of problems with this, but it seems fine. Maybe because I just copy paste up here to down here and all that. But anyways, so you can report in your thesis that multicollinearity of the data set is achieved because the values of tolerance and VIF is not more than 0.01 for tolerance and not more than 10 for VIF. Okay. Now, so one test pass. All this, yeah, you don't need to see lah, huh? Oh, scatter plot. So I did scatter plot already, but do I want to show? Let me see. Okay. The scatter plot, okay lah. Maybe let me show one more time lah, huh? So now, after we check for multicollinearity, we would want to check univariate or normality or linearity. Okay, so if your questionnaire, everything is Likert scale, 4, Likert scale 5, Likert scale, it should not be a problem. Okay, because people only have 1 to 4 to answer or 1 to 5 to answer. So most of the time, you don't even need to check for normality or linearity for the latent variables. However, maybe for age, education, the demographics lah, normally will have like a little bit of runaways and, you know, those outliers and oddballs. So let's just try it out. Okay, so for this, we go to graph. We go to legacy and we go to scatter. Where is scatter? Scatter and dot. We choose matrix scatter. Okay, define. Okay. I want to be fast just now, so I just did everything already because we're running out of time and I talk a lot. Now, okay, so I put everything in here in the matrix variables. Even though I mentioned that all these latent variables are measured on a Likert scale, it's fine. I just lump everything in. It's fine. It's just that this ID, don't put it in, yeah, because ID is not your data set. Okay. Now, theta, I don't think there is anything else. So, okay. We'll let it process for a while. I think my laptop has reached its limit. Just now when I did, it was okay. But anyways, all right. Anyways, if you follow that step just now, what it will give you is this. Okay, it's the same thing. It's the same thing. I'm just showing you like two separate ways of doing it. Okay. Now, after you have gotten this scatter plot here, okay, what you do is you double click it. You can see this. Yeah. You can see the scatter plot, right? In another editor. Oh, this one. Okay, can you all see the new scatter plot in the chart editor? Because I'm scared you guys cannot see. Yeah, so from here, you click this, add fit line at total, okay? So you add a fit line. Now, what you want is, right. What you want is a lowest line. Okay, a lowest line. Not a linear line, not mean, not quadratic, not cubic, but lowest line. All right, so everything is already inputted here for you. So apply, and then see, you get your lowest line already. So what you can report here in your thesis is that normality, let me see back the terms. Because there are 3 terms that you can use. Okay, let's use univariate lah, because we didn't really use the linear line. Univariate, okay? So your data set has passed the univariate test, whereby your scatter plot, how do I say this? I forgot how to properly sentence it out, but essentially you should report that your data, the dots inside of your scatter plot has a has an acceptable lowest line. Okay, you see, lowest line are supposed to be like a curve like that. Yeah, so it is something like a lowest line here. So you can say that achieve lah. Okay, it is univariate and let's achieve. Oh no, I'm sorry. Okay, linear is linearity, but this one is actually homoscedasticity. No. Because just now it didn't come out. This table cannot be used. Wait, let me try again. Hopefully it works. Come on, go to garage. That works. Okay, another way. We go to do linear. Another way lah, another way. We don't use a scatter plot. We use another way. So statistics, don't use this one. Just normal. Continue. Plots. Now this one is for later. Because just now I did the entire thing to make it faster. So it's now overlapping. Try to see this one. Significant. Okay. Right, we get another scatter plot now. So when I do linearity, actually anything that is not significant is not linear. So nothing is linear here except for like a few, this one. Yeah, just the significant ones are linear actually. Yeah, can you see? Yes? Where am I now? Screen editor again. Okay, let me go to output. Okay, I'm at output now. Yeah, it's fine. Linearity test is pretty easy. So anyways, whatever that is at the significance here, that is not significant, is actually not linear. Okay, because as I mentioned, this data set, I just do up for our demonstration. So you can see race is linear, gender is not linear, age is not linear. So if you have linearity problem, you really cannot use structural equation modeling. So that is really important for you to test for linearity lah. Okay. Now, for the one just now, yeah, the homoscedasticity, okay. So after linearity test, you do homoscedasticity, you go analyze, you go regression, you go linear again. Okay, it's the same thing. ID don't put in, but you put in all your independence. You go to statistics just now, we already, okay, I just put in back, continue. The plots, okay. For Y, this is important, yeah. For Y, you put in Z resid, okay. For X, you put in Z pred. Where you get it from here, see? Okay, you just input it like this, okay. Now, continue. Okay. Same thing came out because I clicked yes to the collinearity just now. Yeah, so for you, if you were to do, you don't need to do step by step. You just click everything and everything will come out. Okay, I did it one by one because I want to show one by one. Okay, so scatter plot just now is the same. So you click it on and then you go to the fit line. You don't choose linear, you choose lowest and apply. Okay, homoscedasticity. I'm not showing the chart editor. Okay, so it's the same thing. So this one, sorry, the lowest line is for homoscedasticity. Okay, homoscedasticity, right? So you can say that homoscedasticity has been achieved. All right, because of the lowest line. Not linearity, yeah. So let me close it. Let me go back to output. Go back to output. Okay, wait. There are too many. Where's the chart editor just now? Okay, we're back in output. Right. Then after this, after we do multicollinearity, we do linearity, we do homoscedasticity. Now, the fourth requirement is invariance test. Okay, this is the fourth one. So how to do invariance test? You go to analyze, you go descriptive, okay, and then you go to descriptive. Okay, I also did this already just now. So I put everything in. right? Except for the ID, yeah. So you go to options. You only choose variance because you are doing invariance test, all right? So you do variance only, okay? For the standard deviation that we did in Excel just now earlier, to see whether there is unengaged responses, you can also do it in SPSS here, okay? You can explore yourself. Just now it's just an alternative lah. So variance, you click variance, then continue. It is just like kurtosis is now, right? Continue and okay. Right. So what you get here, what you are interested in is really just the variance. So how do you read this? So you can say that you have achieved, you have passed the variance test by looking at the variance value, whereby none, okay, luckily, none of the, how do I say this? None of the values of the variables are more than 10. Wait, it is not more than 10. It is, how do I say this? None of the variables are 10 times more than any other variable. Okay. So it is not more than 10, but none of the variables are 10 times more than the other variables. So you can maybe choose the highest number, and then you see whether there are other variables that are 10 times more, or you choose the lowest one, and then you try to see whether there are any other values under variance that are 10 times more. Okay. I think area, if it is 10 times, there might be some problem here. But anyways, okay. So for variance test, if you want to report it, you can say that, yeah, it passed lah. Okay. Now, right. So all of these are the assumptions for the data set, right? Now, once you have all these passed, everything passed already, data is very pretty, very good. You go back to Amos. It means that the data set is good lah. You don't need to delete anything. How do I do this? File, new. Okay, never mind. I want to show the pattern builder, but it's fine. It's okay. You can go explore yourself. However, oh no, I cannot do this. I have to do, now we have to do unidimensionality. Okay, so I think just let me, okay. I just save a new one, save as. Save as, I save 6. The window. Yeah, I have to share to here. Right, okay. So I am in okay, so I am here now. So I wanted the next step is unidimensionality. Okay, so I want to do unidimensionality. What is unidimensionality? You want to check each latent variable along with their own respective manifest variables. This small model fit or not. Okay, that is what you want to know. So you go, because I already did this entire thing, let me just save as, and then I'll go to 6, and then let me label it as unidimension, and then this one is for, let me see now, what is this? FSAC, unidimensionality for FSAC. FSAC. Right, see, the 6th one is here. Okay, so that is my data. Now, because I only want to see FSAC, so I don't want the others, so I have to delete it. Oh, what a chore. Okay, even this, because I did some tests on it just now. Let's just delete it for now. So unidimensionality, analysis. So all these things are prepared, minimization, standardized, covariance, correlation. Okay, actually we don't have correlation, covariance yet. Critical ratios, because we do not have anything to correlate yet, right? So just take a bunch of it. Okay, close, save. Now we try to run. Run. Did I read the file? Ooh, not found. Okay, let me go back here, file name. Let me go, no, maybe I'll go put it back here. Okay, so hope it runs now. Ding. Okay, it ran. It ran. Okay. You want to know if it ran okay or not? You see the red button will come up. If iteration limit is reached and the computer is not able to analyze your data, then there must be something wrong. Okay, so I'm surprised that this set is okay. Right, so let's go have a look. If you click this, you can see all the beta values here. Okay, so none of the beta values are less than 0.7. So this is very, very, very good. Okay, if you have beta values of less than 0.7, it's actually fine lah. So try not to have below 0.3. Okay, 0.3, 0.5, those are like minimum lah. Okay, but the best is above 0.7. It means that this item is really, really indicative of this item. Okay, now, so don't want to look at that anymore, but anyhow, you can screenshot this and put in your thesis if you want, or you can draw it back lah. Okay, for your unidimensionality test. Now, after you click calculate estimate, you can go here, view text. Okay, let me see where the Amos output. Right, so I hope you guys can see the Amos output. This one is the view text place. So you can see that we have the degrees of freedom and all that. Okay lah, we don't really bother about this, but when we do moderation later, you'll have to be bothered with this. For now, minimum was achieved, and then things are like significant and all that. Okay, we don't need to look at it. Now let's go look at the estimates. See, this is really good, meaning that this is something like linear regression, isn't it? So you can see that food store access is significantly indicated by this question 6 lah, whatever it is. Okay, and it is significant, right? And it carries the weight of 0.9, which is really high. Okay, so if we want to know together, okay, as a whole, this question 1 to question 8, how well does it quantify food store accessibility? We can go look at model fit. Okay, I hope you all can see model fit. Yeah, so you see this model fit. Okay, for model fit, yeah, you choose yourself what requirements you want. Okay, for me, I choose okay, CM and DF is the one that you see just now in front. Okay, the degrees of freedom and all that. 14.9 is not really good, because the acceptable amount should be the acceptable value should be less than 5, preferably less than 2. Okay, less than 2, less than 3, less than 5 is fine. This one is too much lah. Okay, and then I also tend to look at GFI 0.8. 0.8 is okay, but I would prefer 0.9. Okay, and some people will look at AGFI, but I don't. Some people will look at PGFI, but I don't. Okay, I look at GFI and I look at CFI. So CFI 8.99, okay, pretty good, right? Some people will look at TLI, but I don't. Okay, and then what else? We have, some people will look at P close, okay, but I don't also. P close, it should not be significant. It should not be significant. It should be insignificant. Okay, you can go read yourself why, but and in what situation you want to include P close lah. Okay, for me, I generally don't look at P close lah. Okay, Ramsey, for Ramsey, the amount should be the lesser the better. So 0.08 is still acceptable, but weak. Better to have less than 0.05. Even better if you can achieve 0.03. Okay? Yeah. So you have to see yourself which requirement is necessary for you to put in, which are not. Okay. Now, so this for me it's not good lah. It's really not good. C-mean it doesn't not good. 0.8 for me is also not good. Normally I go for 0.9. P close not good. Ramsey not good. Okay. Now, just now we click modification indices, right? See the little helper. The little helper will tell you what to correlate with each other. Okay, now, for example, the one that you want to attack first will be the one with the highest number, which is 100. 166, 68, okay, so let's do, okay, normally, if you do it yourself, you correlate it one by one, okay? However, I think, I'm scared we run out of time, so let me just do it like together. So let me jot down, So 6 and 7, and then what is that? 4 and 7, and then 1 and 2. Okay, we'll just do these 3 first, Okay. So how do we do? We go back to our Amos. Right. So I hope you can see the Amos. Yeah, we are at Amos. So just now 6 and 7. Yeah. So how do we do that? If you are still at this red button here, if you can see the beta values here, you cannot touch anything. Okay, so you always have to remember, don't panic. Always remember to just click back the input path. Okay, here. Once you click here, now you are able to like modify it and stuff. All right, now, so you click this one. Ding. Okay, now you have to covariate 6 and 7. So you don't covariate this manifest variable with manifest variable. No, you covariate the errors, the error terms, okay? So why? Go read yourself. Okay, explore 4 and 7, right? And 1 and 2. Ding, ding. Okay, now, if you want to save it now, you can. If you don't want to, it's fine. So let me just calculate estimates and hope it is better. Yeah, once you click calculate estimate, you go to view text again. Yeah, so let me go share text again. Yep, I think we are here, right? Yeah, so we will go to see modification indices. Anything else? There is still a 4 and 6. I'll just jot it down first in case, right? But let's look at model fit. See, C-min is now 4. Just now is 14. C-min 4 is okay lah. Because it is below 5. It can be better if it can. If permissible, we can make it better. See, 0.95, very good. 0.76, very good. Yeah, P close is still significant, not good, but Ramsey is 0.098. So it's still not that good. So what we do is we go back to our Amos. We correlate the 4 and 6 just now. 4 and 6, 4 and 6. Yeah, 4 and 6. All right, now calculate estimate again, and we go view again. Okay, we're back here. We'll go look at the model fit. See, C-min is 2.3. This is good. So C-min is less than 3, good. GFI 0.97, good. CFI 0.99, very good. Even P close is good now. It is insignificant, meaning that it is more than 0.05 lah. And then Ramsey, Ramsey is still. But anyhow, for Ramsey, if it is this number is this value is already less than 0.08, so I guess okay lah, we accept it lah. All right. So how do you report it in your thesis? Is that for unidimensionality of food store accessibility? You show the what is that? You show the Amos thing just now. Wait, how to show? All right, never mind. You write down model fit has achieved, because and then you do the comma thing, which is C-min DF 0.3, GFI 0.7, CFI 0.9, Ramsey how much, P close how much, and all that. And yeah, so model fit is achieved. Oh, yeah. And then you optional, you can put in this graphic lah, or if you want to draw it back, also can. So for unidimensionality, you do this entire process for all of the variables. Okay. Now, we only have 8 minutes left. Right. Never mind. So if we were to go back here, right, this thing.
Dr. Hashimah, you can extend more 5 or 10 minutes, no problem.
Okay. No, but I have a meeting at 3:30 and I have some preparation to do.
Okay.
Oh, so sorry. I talk too much. We need more time for this. So it's okay. Maybe next time there's a part 2, right? Because okay, after we do unidimensionality, we for each of the item, sometimes you will find yourself deleting variables or covariate error terms in order to make the entire thing fit. Okay, so after you do your unidimensionality, you will have to do validity tests. Okay, so you can explore yourself how to do conversion validity using Amos. So for conversion validity, you will look at the indicators are the average variance extracted, which is AVE. AVE should not be greater than 0.5. Okay, should not be greater than 0.5, and composite reliability, which is CR, should be greater than 0.7. Okay, I don't have a example. Never mind. Should I do it now? Maybe, yeah. Maybe I do this one last thing. Right. So I try to run this. Okay. After you do dimensionality, you just put everything together and correlate everything together, and then you go calculate estimates. Error again because this is like the old data. So file name, I'll go to get my data, which is the trial data, and okay. All right, now it is updated with the new data, then we calculate estimate. Ta, 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 ta. So it is running. Ah, okay, it is successful. Wow, thank God. Okay, now we go look at the input. Okay, maybe I do off screen for a while. It's a bit faster. Let's see. Data features. Asking. I need correlation. Normally what you need is correlation table and standardized regression weights. So correlation table, we'll go to estimates. We'll open it up. Actually, if you open it up, there are many things in here that you can explore. Now, estimates, there is a scalar. So I'll go to scalar and then I'll go and take the regression weight. Yeah, copy. Regression weight. Then I'll have to go correlation. Where is the correlation? Okay, it's here. Here, copy. And put in the correlation. Yeah. All right. So, oh yeah. Wait. Oh dear. Oh dear. Yeah. Oh, got to do the thing. Wait. We have 10 minutes more, right? Oh, wait. Let me try this one more time. Correlation. Come on, come on. Okay, the laptop a bit stuck. Copy. Okay. Correlation. Standardized regression. Okay. Now. Okay. It ran. Right. So I'm going to show what sort of you can see. Okay. I hope everybody can see this. Right. So you will get this kind of answer. Okay. So you can see here, this one is for discriminant validity. So as I mentioned just now, the two things that you need to look at is the composite reliability and AVE lah. Okay, so composite should not be composite should be greater than 0.7. Everything is above 0.7, and yeah, AVE should be greater than 0.5. So everything is greater than 0.5. Okay, so validity of the measurement model has been verified, okay, and achieved, right? So what happened if, let's say, one or two of this has a problem, like this one is red and this one is red? What happened here? This is quite a big problem, because if you did not achieve discriminant validity, you will have to go back all the way to EFA stage just now and redo everything, like to just experiment, maybe still take in a few variables, or maybe take out other variables. You just have to play with it and experiment with it until you get a good validity. If not, your data set is really not suitable for this analytical method. Okay. Right, so after validity and everything is done, okay, we will do one more time. Yeah, since this has no problem, good. Now we shall go back to our AMIS. Okay, we go back to AMIS. And then we look at model fit. Okay, we haven't looked at model fit yet. Validity has achieved, but model fit of the measurement model, not yet. So let's calculate estimate. All right, let's look at the view output. It's here. All right, so let's go look at the model fit. C mean is 1. Wow, very good. GFI 0.95, good. CFI 0.98, good. No, P close, insignificant, good. RAM-Z below 0.05. Wow, okay. So model fit is achieved, right? How about we go look at modification indices? See, nothing should be changed according to our little helper here. So this measurement model is established. Okay, so we have succeeded in the first part of, not really the first part lah, but like almost half of CFA. Right, now next is common method bias. My God, so many. Now, so common method bias, let's go back here. Okay, why we need to do common method bias? Right, so I already did one here. Let me just see. Right, this one. Okay, now common method bias is we are scared if there are other things that we did not account for. Okay, so how do we do that? I already did this thing. We add this one large thing here. You just use this thing, this circle thing, and then you put CLF. There are many other ways to check for common method bias, but I choose to use this method lah. You can explore yourself other methods. And then when you click here, you put in CLF and you have to put in parameters. I have to put in 1 for the variance. Okay. And then you close. So you see the 1 is here. Okay. And then you use this line. You connect to all the manifest variables only. Okay. Right. And then you try to run. For me, this is the most simple way to do common method bias lah. Okay. Now let's save it. Wait, let me check this data. Yeah, is it the data that I'm using? It's different data. Oh, yep. Okay. Now it is updated. Calculate. Proceed. Looks like our luck has run out. Since this is a hypothetical data, yeah, it did not run. Iteration limit reached. It means that at this stage, the data. Sometimes, okay, then if in this kind of situation, I would try to use other methods to try to establish my common method bias. Okay, but because I have 7 minutes left. Yeah. Normally we will not have problems with this thing. Okay, but because this is hypothetical data, so it cannot run. However, what you want to find out from here is that after you click this, you click the calculate estimate, it will come out, you will have to look at the standardized regression weights. Cannot, okay? You have to look at the standardized regression weights, and when you look at that table, okay, memang tak boleh, cannot. Okay, let me go back to, Let me go back here. Just use this as an example. Okay. You need to look at the standardized regression weights. Okay, let me show standardized regression weights, which is this one. You go to estimates, you can see standardized regression weights. So loadings that are more than, okay, if just now we have the CLF, you will see all these things plus with CLF to FSAC6, CLF to FSAC7. So all the CLF will appear here at the standardized regression weights here. So what you need to do is look at the original one and see if it is still more than 0.7, these original ones. If it is still more than 0.7, meaning that by adding the CLF into your measurement model, it did not lower the factor loadings of your estimates here. So it is a good data set. So it means that there is no indication of common method bias presence in the data set. Okay, if that happens, which is good, we will delete the CLF circle just now in our model. We will delete it out. Okay. However, if let's say your estimates are less than 0.7, suddenly by adding the CLF in there, adding the common latent factor in there, your estimates suddenly become like very low, 0.2, 0.3, even negative sometimes. So it means that there is a presence of common method bias in your data set. So you will have to retain CLF thing, that circle thing, in your in your construct lah, okay, in your model, right? Okay, so I'll go back here, right? So I want to, after this, after you have established all this, measure model all good, you would want to impute your data. You want to do data imputation. So how do you do that? You will go to analyze and you do data imputation. Okay. Just now I try already. This data set is not that good. So data imputation is not successful. Okay. However, let me try to open, let me try to show you what a successful imputation will look like. So after you click data imputation, Amos will save a new data set in SPSS for you in the folder that you want. Okay, so like for me, let me open this one. Yeah, right now, what you are looking at is this. You see reliability test. Wow, this one is like data set back in 2018. Wow, right? So Amos will save the imputed data as C. Okay, C means composite lah. Okay, so if I scroll down, you will see all your original raw data, and Amos will add things for you. It will add in these. You see the CLF just now? Okay. See? It will impute all this. What does imputation mean? It means that all of these data just now will become one. So food store accessibility, it will not become like this anymore. It will just become a rectangular on its own. So you you know that that rectangular already included all these FSAC 1 to 8, already included. All right. So if you look at this one, it will not show as it will not show as this one anymore, because you see this one, you still have the latent variables and the manifest variables, right? So after you impute, if you drag it out, it will become very simple, very simple. How to show leh? Okay lah, never mind. But I think we have gone through everything that needs to be explained. Yeah, from the validity to the reliability and to the building of the structural model. So, and we have gone through all the fulfillments and all the requirements that are needed in constructing your draft. All these are only draft for your draft structural equation modeling. After you impute data and you put in a full version like this, that is when your real research, your real experiment starts. At that stage, you are able to report your direct effects, whether it is significant or not. Remember the mediation that you found, then you are able to use all these lines and do your lines lah, okay? To do all this, to do the mediation, and then with this data set that has been checked for everything, you can do your moderation. So moderation is the multi-group, right? So multi-group is here. You last example lah. So for example, just now is urban, new, and rural. You have two, right? Close. So you have two. Now, when you go back to this select data file set, you see two, urban and rural. So you will have to tell Amos that urban is which one. So if we go back to SPSS just now, you will know that, let me go back here, area. Okay, last. Okay, you will see that, you see urban and rural is 1 and 2, right? So when you go back to Amos, so when you go back to Amos, here, you will click file name. And then you see this grouping variable. You group by area, right? So you put area, okay? And then group value. So just now, you remember 1 is urban, 2 is rural. So you put 1, okay? And now rural, you go to the same thing. So file name, you go find a file. And then grouping variable is area, and then group value is 2. See? So now you have group 1 and group 2. Okay. Okay. Oh, okay. Wait, did I press something? I'm sorry. I was still showing stuff, but
No, we can't see your slide.
yeah, suddenly it stopped.
Oh, maybe you can share again.
But it's okay, it's okay. That was the last thing that I was going to show.
Oh,
So that, yeah, so that one is when you want to do multi-group. All right, multi-group, yeah. Man, I talk too much. Next time I should you know, just straight to the point and stuff. But yeah, I hope everyone is not bored out and is able to learn something from this workshop,
yeah,
from this talk.
everyone listening you.
No. Thank you. Oh, can we take a picture? Wait, let me
Sure.
show. Yeah. Oh, Fazila, are you Prof. Suhaiza's
Betul lah.
student? No. Oh. Hi. Are you UM student?
Yes, I'm student.
Ah, okay, okay. Yeah, yeah, come, we take a picture. Oh, people are starting to leave now.
Do you know
Ah,
him?
hi,
Do you know him?
Lau. Dr. Lau, I miss you. Okay, okay, come, take picture. So how? Who take picture? Me or you?
Okay, I can take picture. Okay.
Thank
1,
you.
2, 3.
Okay, one more professional one.
Yeah. Smile.
Hi, Yang.
One more. And rest of them, maybe they're sleeping, right?
Oh, it's okay.
Okay, okay. 1, 2, 3. Okay, thank you.
Thank you. I really hope everybody has learned something. I'm sorry if like some certain part I rushed through or like I made mistake in certain parts, like the factor matrix just now. I
No,
confused
it's
between
okay.
the two tables.
I think that is okay. They may have the basic idea because you can't teach within 3 or 4 hours whole PhD. So it's not possible,
Yeah,
right?
this
They
is
should have
only, yeah.
they should have some stress and depression, then they will learn more. Otherwise, it will not work.
We need to get this workshop video recording. We can get it.
Sure. All of you already send the email address. I'm not sure.
No.
Send then I'll send all of you.
Message. Okay.
Yeah. In the chat box, please send all of your email address. Then I can.
Okay. Thank
send
you.
all of
Thank you, doctor, so much. We really get benefit.
so much. We have more session, but I'm not sure that all of them are from social science or urban planning.
Yeah, I also not sure. But Suhaiza is a professor from UM. Thank you, Prof.
really?
Su. Yeah, thank you, Prof. Suhaiza, for being here like for hours some more. Thank you so much. And she even helped me share to her students. Yeah, she's currently the director of one of the centers here in UM.
Oh,
Yeah, Unku Aziz Center.
maybe
Yeah.
get with her or no? In your
Huh?
faculty or different?
No, she's from another faculty, not under our faculty. Oh, she has gone mute again, but okay, maybe she's doing something, so let's not
Okay.
yeah,
Okay,
but
okay.
thank you everybody.
Thank you so much, everybody, for joining. And maybe in future I will share and see you next time. And thank you so much, Shima, for your time.
Yeah,
And we'll
please
invite
keep in
you.
touch. Yeah, please keep in
Sure.
touch.
Bye-bye.
Bye.